use technologies such as video, Desmos, and etc. We think the potential technology in mathematics learning can be helpful for our students to have most important, I think, critical thinking and also the creativity and collaboration among students. Here are right now, today, our keynote speakers will deliver and also discuss how to better harness the potential of technology in learning mathematics. If there's any comment, suggestion, criticism, finally, I declare the international idea how to better harness the potential of technology in learning mathematics, officially open. We wish you all a very good webinar. Stay safe and stay happy. Thank you very much for all of you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Mario, for inviting me and has officially opened the meeting. Ladies and gentlemen, the mathematics education community has recognized the importance of technology in facilitating students to learn mathematics. However, many teachers still face challenges when dealing with technology in their mathematics classroom. The lack of knowledge about technology and how to use it effectively to enhance students' mathematical understanding are some of the challenges. As an and it is expected that the event will foster the exchange of ideas and strategies for the better integrations of technology in the mathematics classroom. Ladies and gentlemen, before we start the keynote address, allow me to read the webinar protocol. The webinar is recorded, and participants other than keynote speakers are muted. Participants joining from Zoom and YouTube should fill the attendance list through the link provided in the Zoom chat box and YouTube description. In the end of the webinar, participants should fill in the evaluation form provided in the Zoom chat box and YouTube descriptions. That was the webinar protocol. Remember, the protocol is for dropping the questions in the Q&A box. The keynote speaker will present for 40 minutes, followed by 20 minutes Q&A, and then for the Q&A sessions. For participants joining from Zoom, they may leave their questions in the chat box, and then selected one participant will be given a chance to ask questions directly. And for participants joining from YouTube, please leave the questions on the link provided in the video descriptions. And ladies and gentlemen, I have very good news for you that we have provided giveaways for the webinar. All participants have the same chance. For those who join through Zoom and YouTube, please, here is the easy way to do. How to win the giveaway? Please, the first, follow CP on Instagram at @event. And second, please capture the webinar by taking screenshot or recording during the webinar. And the third, please upload your capture, your screenshot of pictures of our video, and please upload them to your Instagram story and mention at @event. And the winners will be announced this weekend. Thank you. And ladies and gentlemen, without any further ado, we will begin the sessions, the first sessions of keynote address, the sessions of Mr. Tim Besinski from the Wellingford Public Schools, Connecticut, USA, and the sessions will be led by the moderator who joined us online today. She is Dr. Lufixa from the Institute of Promotions and Technology.
group, but the song and the struggle on how to use it effectively. Our Lufixa, we use it university, it can share with us how to enhance digital learning using technology. We use it university is an mathematician. He is a teacher for the one public school and a part-time internship and mathematics education component at the residency unit. He is the former professional development director at the Lufixa and a former full-time internship and mathematics education component. Teacher, educator, and author. Prior to this, he was a full-time high school mathematics teacher at Berlin High School and a part-time mathematics instructor at Central Connecticut State University for 40 years.
New York time zone here, so it's 10 o'clock at night, but anywhere where there's that tech, I'm excited, I love using it. And my passion, my philosophy of education really, in 6 words, is active, student-centered discovery-based learning. I want the students to be at the center of the learning, not the teacher. I want those teachers to be a facilitator of that discovery. And I use a lot of ed tech apps to do that. So tonight, we're going to take a look at Desmos. I've got a shirt here going on, the Desmos shirt here. But we're going to look at Desmos. And I don't know how many of you heard of Desmos, but it is one amazing app. I love using it. My students love using it. And you're going to experience tonight, I'm not going to lecture for 40 minutes, but I'm going to have you actively engaged right by your computers. And you can see the training. I just did it as of now with the local Brzezinski map there. But that is it right there. I will share my screen, if that's okay. Do that. And yeah, here we go. Okay, I'm assuming you can't see my screen there. So Desmos is awesome. All right, now I'm not so much about Microsoft PowerPoint or Google Slides. I'm not so much about the slides. There's some links there, but I'd like to just really take you on a journey. The place you really want to go to is, if you go to Desmos.com, I'll just go there myself. You can go there with me. Just type in Desmos.com. And you get a very beautiful looking site like this. So Desmos has a few apps, which I'm sure some of you have seen. They have a graphing calculator, scientific calculator, it's all there. But I absolutely love the activities for teachers. Desmos has a team of educators and engineers, programmers. They have a team that they author and they curate many activities. They do research on these and they test their effectiveness and they go back to the table and they revise them and they make them even better. Okay, so we're going to go browse activities here and you'll find a lot that you can choose from here.
There we go, just put it in. And let's see. Okay, now I'm gonna also join the class as a student as well. Now I have a teacher here, right? Now I can see on my screen, all the students who are in so far. Okay, now you're gonna be on your own tab, right, in your Chrome browser. I'm here, but I see people here who have started the first task. Okay, and I can see where every student is. Now this is very powerful with respect to students. You know, many countries are still in a hybrid model. Some students are physically present in class, some students are home, right? And every day that could change. Continuity of instruction has been so lost because of the effects of COVID-19. Right? It's important for continuity of instruction to be preserved as much as possible, while simultaneously giving students an opportunity to engage as much as possible. Desmos is an awesome tool to help teachers do that. I love Desmos. From the bottom of my heart, I love Desmos. Yes, I've used GeoGebra for years. I love GeoGebra too, but Desmos is very intuitive. It is very user-friendly. It's and I'm just going to show you some examples. Many of you right here have already started playing with it and seeing what it can actually do. But let me just look at it from the role of the student here, just to show you. All right. So checking in with students, you know, emotionally to see how they are doing. That is very important. Yes, learning and teaching math is important as well, but it's very important when students are not in class that you have a way of seeing emotionally where they are. And just a simple screen like this can help students communicate one-on-one with you how they're feeling. Okay, so I like to intro, on days I use Desmos, I like to intro with what they call a starter screen. Desmos has an entire collection of these starter screens. I'll show you where they are later. Okay, and over here, this is a pretty cool feature Desmos has that I absolutely love. Students love it. It's called Marble Slides. So you might have seen it before, but here students have to build or create. Now the goal here is to change this equation here in order to create a ramp that makes the ball knock into all the stars. So I'll try that right here myself, if I might. I know the slope has to be positive, right? It gets students thinking. So maybe 2. Ooh, that might look good. But if I launch the ball right now, see it. Now I have to make the domain a little bit bigger, right? See, students can have these conversations with their teacher. They can have these conversations with each other. Okay. So right here, I might want to make this X bigger than 5 or 6. I think 6 might do it, right? And you see, there's a success. And that success is actually reflected on the teacher dashboard, believe it or not. Because, let me just see something here. Yeah, because right there, okay, I can actually see, let me just refresh here. Sorry, my bandwidth is slow. But I can actually see when a student is successful, I'll see a little check mark on my dashboard here. Okay, it's pretty cool. Okay, sorry. Okay, but right here, let me just go back. There we go. See, I could see all students here in real time. Look at that. I can see where they are. That this is the teacher view of every student in the class. I can see where they are. Now, this is a huge class. There's hundreds of people here. No, so, but if you have a class of 20 or 30 students, it's easy to keep track, formatively assess their progress in real time. It is amazing. And the summary here, if I go back, you see here I could see which students have successfully completed the marble slide activity. And I could also see which students are still haven't started and which students are still working on it. Okay. Now, I absolutely love this next. I want to show you this next screen 3. If you go to the third screen, okay, in the upper right corner, you'll see next there. Let me go to this one here. This is the third. This is the third screen of the activity. But look at what you could do with Desmos here. This is absolutely amazing. But you can have students create their own graphs and watch an animation. Watch this. Distance versus time. I'm sketching my own graph and I play it. Look at that. That is amazing. Students can make powerful conceptual connections between a function expressed as a graph and actually interpret that function with respect to contextually what is really happening here. Here, we're actually looking at the distance the turtle is from the water with respect to time. But let me go back and erase. You can always erase. This is a sketch. This is a sketch here. I can erase it there. By the way, this was taken from, if you really love this activity, this was actually taken from Turtle Crossing. That was an activity. The whole activity can be found in that hyperlink right there if you're really interested. Okay, there's a lot of them. But I always ask the students, what would it look like? What if I did, one of the questions, what if it looked like this? What if a distance versus time graph looked like this? And I ask students, how would you describe what happens? Well, what would it look like? If I played this out, what would it look like? Well, now I can. Watch closely. Ooh, why are there 2 turtles? Where did that come from? You see what I mean? And in the Desmos activity from which this came, the activity asks students to actually sketch various models of, they give a story. Can you sketch the model? Can you predict what it's going to look like? See, there's a lot of higher level thinking going on in activities like this for students who are present in class and for students who are home. But regardless of the venue, whether you're a student with me right now or whether you are thousands of miles away, you're thousands of miles away on the other side of the world. But yeah, I could see your progress in real time. That's the power of Desmos. It's amazing. One of their mission their mission statement is to, I think, something like they want to get students to love math and love learning math. And they do an outstanding and amazing job at it. It's just unbelievable. Now, you can build these activities yourself. Now, something like this requires some advanced programming called computation layer, which we're not going to touch tonight at all. But you can, if you go to the fourth screen in the activity, you can actually create matching exercises. These are called card sorts. Okay. Again, not a higher level thinking task, but card sorts are great for when you want to have quick matching exercises for students. So for example, this one asks students to match 4 slopes with 4 pictures, right? So right here, I could actually click on a card and make it larger. Oh, that slope is 5 over 5/3. So I will put this one over here. If you actually put a card on, put 2 cards on each other, you could start forming pairs. You could even put more in one, 3 or 4 in one. Which belong, which don't belong. You can ask lots of different types of questions with card sorts here in Desmos. Very, very easy to do. I'll show you how to do that later on in the talk. Okay, so obviously let's get this right here. So you know this goes here. So we can quickly assess students in real time. Now, I have to admit that the level of complexity of this task is very low. This is not a higher level thinking kind of question. This is true, or this is like on the level of true, false, identify, list, match. That's lower level thinking. And in a 21st century world, any kind of questions we give students, the few questions we give students that have them do something like this, the feedback needs to be automatic. Teachers should not be wasting time collecting papers and looking at B, C, B, A, B. We could have a computer do that, right? Teachers are needed. We want to actually spend time analyzing students' higher responses to higher level questions, like the turtle one I just showed you, if that makes sense. Okay. Now, again, many features, checkboxes. This is an example of checkboxes here. Which of the following functions are even? You know, again, quick assessment pieces. You see what I'm saying? And on my teacher dashboard, I will see a check if you get it right. I'll see an X if you don't. Okay. And so the possibilities are endless. Like here, this is called an ordered list. Can you list the following quantities from least to greatest? Okay. So again, simple, basic questions. And also, right here, this was a question authored by the Desmos team. Can you create a rectangle with an area of 24 and a perimeter of 22? And I think it's actually 3 by 8, if I remember correctly. Right, 6 and 8 is 14 and 8 is 20. So I try it and it fits. But if I reset it, let me try 2 by 8. Let's see what happens there. Oh, gosh, 2, not quite, right? So you see what I mean? So Desmos has a lot of curated activities. I'm going to take you on a little journey with that. As a student, that's like a little sampler of what you can expect with Desmos, but you can learn a lot just by simply browsing what they have on their site. It's a very beautiful site. It's very well organized, clean, right? Unlike other sites I've explored in the past, but it's pretty darn amazing. So yeah, that's a little sampler of Desmos looking at the role of the student. Now let's put on the teacher hat. Let's actually walk through, how do I find an activity? How do I build a Desmos activity? Okay, we'll go through that next. And can I ask a question? I know I started before 9 o'clock a.m. Do I still go to 9:40 a.m. or do I stop at 9:30? Like, how do you want me to, what time do you want me to end?
I think it's up to you. I think for me, you can, do until like 9:40, I think, because it's quite, kind of quite fun.
Okay. Hey, well, we'll have a lot of fun with Desmos. Totally cool. Thank you. Cool. So let me go here and back to the slides presentation here. Okay. Anytime you find an activity, I mean, I just put the PowerPoint there just to have references. I don't like to look at it during the talk, but let's just go to Desmos itself right now. Desmos.com. Okay, here we are. So now I'm a teacher, so I'm going to go to teachers. But before I do, maybe some of you want to do it now. You might want to take the time to go up to the corner where it says sign in. It's important to create a Desmos account first. If you want to copy things and save things, make your own things, you obviously need an account just like any platform. So the place to do that is up top there. Okay. So if you want to take a minute to do that, you may. Yeah. And the place where teachers go is teacher.desmos.com. Okay, which is where this place right here takes you, where it says teachers. Okay. Desmos actually just released an amazing middle school curriculum for grades 6 to 8. They have a few free samples there you could try with your students. The rest of the curriculum is preview, but I've explored a lot of middle school curricula here in the US, and I could tell you it's my favorite. It's the absolute best. It really is. Engaging, amazing, and yeah. So anyway, but that's where you could preview that curriculum. If you're a middle school teacher, you definitely want to check that out and see that. So and it's a very reasonable cost too for school districts here in the US and definitely internationally as well. But we're basically, you could search for activities here. You can create your own, but I want to show you something here, for example, like linear functions, right? These are popular topics. So, find things, but these are activities created by the Desmos team, and they have been polished. They are top notch. In fact, that marble slides activity that I showed you can be found right here. I stole a slide from there. And basically, if you have Algebra 1 students who are working with linear equations, you could have them do that. Now, you can preview, you can preview this activity by going to the screens at the very bottom of your screen, okay? Teachers can always preview what an activity looks like at the very bottom. So, show you what I mean here. So, right there, it just tells students, hey, this is the launch button. The goal is to knock down all the stars, right? And so here, now look at the directions here. Change one number, just one number in the row below to fix the marble slide. Just change one. See the progression? It's not like I threw something at students and say type something. Desmos scaffolds their activities, right? We start with something easy, we work our way, we ask the critical thinking questions along the way. So obviously it's a y-intercept issue, right? It should be down a little more. Maybe I should make that a -1. Nope, -2. Yeah, I think that'll work. Maybe make it -2.1. I hit the launch button and I get a success, right? And so you can always test an activity out to see what students will experience by going to the very bottom of the activity. You'll see the preview screens right lined up down there. Okay, the next button there. Now we have to change another number. I guess in this case it's the slope, right? 1/2. Launch it. There we go. By the way, if you like what you see, you can create your own. You can actually tell where Desmos to put the purple ball, and you can put the stars anywhere you want, and you could create your own challenge. Parabolas, conics, trigonometric functions. I've seen teachers and students make some pretty hard challenges where balls are going up into curves and dropping down chutes, and it's just unbelievable, right? It's pretty cool. So that's what you could create. And now we talk about domain restrictions. So see, we slowly work our way here until we get to something like this screen. We get to something like this screen, say right over here. Where is it? Maybe that's it. Like this, no, it was one of the next few ones. I think it was screen 15. But anyway, it gets progressively more difficult. But the thing is, it's scaffolded. It's challenging. It gets students to think. So even here, for example, in another challenge marble slide here, right? Now they're asking students to type as many equations of lines as they need to collect all the stars. Again, the possibilities are endless, infinitely many solutions, right? All students have to do is come up with one. But see here, I would rather have students. Now, this is a great means of alternate assessment. What do I mean? It's like with COVID-19, giving out those paper-based exams, put your calculator away, no phones, right? It can't exist in this realm. It cannot. But can we as teachers assess students in their ability not only to perform mathematically, but how about we test their ability to create mathematically? Here we make mathematics an art, right? And Desmos actually has art projects. They actually give the Desmos Poster Art Challenge, I think it's called. It's at the bottom of their website. You can check it out. But students all over the US and other parts of the world have, created some amazing, beautiful pieces of art just by typing in equations right in the left side there. So I'm thinking here, well, maybe I need to put a ramp here and then another ramp maybe collected over here, right? So see, it gets students to think negative slope, domain restriction, they type it in, okay? So and by the way, they also have it for, I think they have marble slides for every type of function students learn, like quadratics even. See marble slides right here, parabolas. Now, if you like it, let's suppose you like it just as it is. You see right here? I'll give you an example. You have some sample responses that could work. But see here, they want students to fix this quadratic here in order to get the stars to knock down somehow, right? And so again, this isn't the only, by the way, students won't see this if you make a session out of it. This is for the teacher only. but there are ways to do this. So if you like an activity you see in Desmos and you want to use it as it is, what you have to do as a teacher is go to where it says assign, right up here. Now, you could create a single session code, which is what I did previously to have everybody here join, right? But if you use Google Classroom, you could sync your Google Classroom classes up to Desmos so that whenever I want to assign, I could assign it to my Google Classroom class and it automatically appears in Classroom, either as a draft or posts immediately. Again, it's very simple. You just click on link Google Classroom, it's all there. Very simple. Even trigonometric functions. If I type in marble slide, there it was, periodics. It's right there. I can now do it with trig functions. Okay. So in this case, right, goes to launch, knock out all the stars, but look at screen 2. Can you change one parameter in the sinusoidal function? And now to get the ball to knock out all stars. See, it's a beautiful platform. I mean, I'm partial to marble slides. I love it, right? Students love marble slides. Teachers love marble slides. It's amazing. But that's not the only thing, of course, but it is pretty awesome. It's pretty impressive. So I'm going to show you how you can actually create your own custom activity. But let's suppose I want to steal that one right there. I like this screen. So you know what I'm going to do? I'm going to go up here and I'm going to copy it. I'm going to author my own activity now. I'm playing teacher. I'm going to author my activity, but I love this screen just as it is. So what you could do at Desmos so easily, you just click this button up here, copy the screen. Now I'm going to paste it into what we call Activity Builder. Activity Builder is where teachers build Desmos activities that actively engage students. And that's where we're going to go now. We're going to plan for active instruction, whether students are home or whether students are in class. The point is they need to be engaged. They need to be the critical thinkers. See, this is the antithesis of direct lecture. It's the total opposite. Students, like teacher, is not the center of attention anymore. The students are in the center of attention. That's why I keep saying active, student-centered learning. Desmos is a perfect setting to make that happen. So let's do it. Now, I need to be logged in, which I am, okay? And where I want to go now is right here, custom. Okay, I'm going to create a custom activity. Or actually, this is custom activities I have here. I have a few custom activities I made over the last few months, even the one I did here for the talk. But right here, I'm going to go to new activity. Okay, new activity. Sample Desmos activity. Let's build, exclamation mark. And then I create. So here we are. Now this interface is pretty powerful. Now these are called screens. I could add screens. Remember the screens we had, this little plus icon right here? I could add more, right? I can delete some. I can shuffle them, move them around. Okay, pretty neat. But let's actually take, you know what? I'm actually going to take something here. I'm going to go to another site for a second. Teacher.desmos.com, because I know it exists, but I'm going to find the starter screen that Desmos has. I'm going to check in with my students emotionally, social emotionally, see how they're doing. Starter screens. Screens for checking in. You could shop around. It's pretty cool. See, how are you feeling? How are you feeling today? Tell me what's going on. Simple, right? Desmos made this. Again, remember, if I want to copy it, I could copy that screen. Okay, and now, whoops, not there, not there. I have too many tabs open. Here it is. No. There it is. Now I can actually, if I just paste Command V. It goes right in there. Again, I copy from any screen there. Copy it right up there, and you can paste it in your own Desmos activity. I do it all the time. Teachers do it all the time. Here in the US, we do it a lot. Okay, but now if I want to see what it looks like, I go up here, not publish, but I go to preview it. I could preview it as a student. Okay. This is what the student sees. Again, they don't see teacher moves, but they see all this. All right. And you could type in here. You could even type math in here. Like actually this, I'll show you quickly when you want a response. You could have students insert an image in a response. They could type math and they could type regular letters. It's pretty cool. And it's very, very user-friendly. But you'll see feedback instantly on your teacher dashboard. All right. So now, here we go. Now I'm going to show just a couple things here. Maybe one of the ones to write. Some students teachers like to write a note to students. Hey students, please do the following, right? And they do that, but students need to type in text here, so that you put text input, or I might have to have some math input. But you see here, you can actually take these items and move them around. Like you could shuffle them around. It's like you're building your own website, but you're building an activity, right? So, hello everybody. And you could put a title of the screen right here. So if I preview it, see here, hello everybody. And I have here, remember this here was the text box. This was the math input box. This is only for math. F of x equals x squared plus 2. So I might want to go here. I might want to go here and say, hey, I might want to go here and delete that component. Delete this. I might want to say, hey, author a function that is odd. And let's preview it. F of x equals, say, x squared or something like that, right? Actually, that's not odd. What am I talking about? That's odd, right? X. And I could submit it, right? Now, I have the option. What if I want to, I might want to ask students to explain their answer and show students their classmates' responses, right? That's up to you as the teacher, but look at when I preview it now. Okay, f of x equals x cubed. Submit. Ooh, now I have to explain, right? And this is where it gets cool. People at home, people in class, I could see all their thoughts. I could read them quickly in real time, and they'll appear one by one on the teacher dashboard. I see it. We'll try it at the end if we have time, okay? But that's an example there. Now another example, I'll show you. Let's do a marble slides in here, right here. Marble slides. Okay, I'm going to choose it. Now with marble slides, you can't put anything else in there. That's the only thing it takes up. Where do you want to put the ball? I'm going to put the ball, let's say, I don't know, -2, 6. Right? I must have to zoom out a little bit there. See it there? There's the ball. And let's put the stars at, let's just make a line, keep it easy, right? Let's put them at negative, let's put it 0, 0, 4. And just all you have to do is put commas in between, a comma. You could put as many stars here as you want, many as you want. So 0, 4, 2, 3. I don't know. Let's try 4, 2, and I don't know, 6, 1. I can go on and on and on, right? Or let's put the ball a little higher at 2, 7, right? It's that easy. But now, whoops, I can zoom in, zoom out, keep it right there, as far in as I want. I'm just using my fingers to zoom in, zoom out, pan and zoom. But right here, now I can, I could test it, or actually, let me, let's say, let's author an equations as you need to crash, to make the ball select all the stars. And so now I'm going to preview that. This is what the students will do. They see the ball, they get that. Okay, well, obviously I just need one. I'm just going to do the equation of line. Y equals negative 1/2 x. Ooh, that's not good. Plus 4. Well, this might work, right? Try it. Yeah, it gets it. But maybe, you know, trying to ramp maybe plus like 3.5. That probably will still work. Again, there's more than one possibility, but that's what the students will experience. Again, with Desmos, you could create some awesome synthesis, creation type questions for students just that get them to think quickly. You just got, again, the goal is to knock down all the stars. They are the engineers. They are the builders. You are not the deliverer of information anymore. They are the creators. So even if I did something like this, y equals mx plus b. Now, I don't know if this would be the setting you want to introduce it in, but I'm sure some of you might. But what if we just had them just experience, wow, what does m do? Hold on a second, hold on. What does b do? You know, the typical sliders we've seen, right? But I might not have any clue about equations of lines yet as a student, but do you think if you gave a student a blueprint equation to type, they might be able to figure it out? I bet you many of them will. And that you do that a few times, gosh, what do you notice? You know what I mean? You see patterns along the way. Again, we're just getting started. Let's add another screen now. Actually, let me actually get rid of that because we don't want that to be in there. We want the student to be able to do that. So now I'm going to add another screen here. Just hit the plus icon there. All right. I'm going to show you a card sort. Okay. Remember the matching of the cards? We did some matching. Again, low level thinking task. That marble size is much higher level thinking, but you know, go for the matching, the true false, fill in the blank. That stuff's easy. We'll knock it off right now. So card sort is right here. It's a full screen right at the bottom. See it there. Okay. And here, now I can add pictures. Look at the types of cards you can add. Math or text. You could add a picture, a graph. Honestly, I have seen foreign language teachers use Desmos when they want to have students do vocabulary, like, you know, apple, the word for apple in this language, right? In Spanish, Monday, lunes. Teacher, you have a picture, have the word, you can match the word to the picture. There are history teachers that use Desmos to list reasons, you know, which of the following, let's say the causes of World War II, which of the lists from least to greatest, which one caused them the most or the least, you know, I'll show that later. But let's actually do some math things. I'll type a math or text, make a large card. If I want math, I just click here where it says type math. Desmos is user-friendly. It's the most user-friendly platform I've ever seen. Y equals 1/2 x. Okay. And then I'll do another card. I'll keep it simple, math. Y equals negative 1/2 x. Make it a large card for students who might be visually impaired. But now I'm gonna have graphs match. Watch this. They won't see the equation. Let's see, all they'll see is that. I'll make that a large card. And here, do another graph. Type it in. And so now I'm gonna make my, let me just do one more here to make it look complicated here. Let's say, right? Y equals 2x. Yeah, we'll go fast here. We could do y equals negative 2x, large card, or maybe I shouldn't have make them all large because there's a lot of cards now on the screen. But anytime that you actually click on a card, it enlarges when you're looking at it as a student. Let me put the matching graphs in there. Okay, really quickly, done. Graph, y equals, just think of how much time you spend photocopy, like if you do on paper, it takes forever. Here, it's quick, right? So now I need to, as a teacher, I'll put in the answer key. Remember, we could see a check on the dashboard. If a student does it right, well, if I want to see that check, remember, lower level thinking tasks, the feedback's got to be automatic, got to be. So I can make that happen by going here. So do that. Now I just need to match them pretty good. So to match them, I just simply do what I need to do, right? So this has to get paired here. That's a match. This is a match, right? Which one? This is a match there, and that's a match there. So that is the answer key. Okay, I do that ahead of time. So yeah, hit done. And, oh, that's a large card, that's why. And so now, and again, I'll just show you one more thing here. I know we have about 5 minutes left, but I'm gonna just show you so you experience it. You have ordered lists from least, order from least, say least to greatest, say 5, 6, again, 28, right? But the thing is, I could, if I go up here, I could use the order as an answer key, and I could randomize the items for students. So that way, when they go to it, it won't be in the same order for the student here and here. Desmos will shuffle them up, and they have to put them in order like you did in the first activity we did. Okay, so right here, let's say something like that, and then there's check boxes. Again, there's a lot of different, whoops, new screen. There's a lot of different things you could do with check boxes here. You can actually have tiles, basic boxes, you know, high, low, by. When I preview it, see what I mean? It looks like that, and you could see that. But you could actually tell Desmos what's correct and what's not correct by checking these in and out. If you do a Google form, it's many of the same things on a Google form. You've done it before, I'm sure, many of you. Same features here, but all in one platform, which is nice. Okay, a Google quiz like you can do in Google Forms. It's the same kind of logic. All right, but now if I publish it, watch this. If I publish this, there it is. Now I can go to assign. Remember, I assign. I could create a session for you. Single session code. We'll keep it good for a year. Create invitation code. And what I need to do as a teacher is go to view the dashboard. That's where the magic happens. That's where you could see everything as a teacher. Okay. So I will give you the link here if you want to see it. Again, we built it together, but now you could take the student role and I'll show you my teacher role for my screen. Okay. So I'll copy it and let's do this. Let's do this. Let me throw it in the chat for you. And let me see if I still have YouTube up there. I'll put on YouTube for everybody on YouTube. I do have it on YouTube. Yes. Here it is. Desmos sample. Join. There it is. So you YouTubers can hop on too. So yeah. So here we go. Some people are in already, but see, you guys are the students there coming in. You guys coming in fast. You are awesome. This is cool. All right. Now you could show me how you're doing. Now, again, there's so much here that I haven't had time to show you because of time, but I will tell you there's a couple things in the upper corner that are very powerful. I mean, there's a pause button. I don't like to do that too often, but man, you guys are thousands of miles away and I just stopped you from working by hitting a button, right? But sometimes teachers like to use the pace, or I could pace. Watch this. Sometimes I want to pace students 2 or 3 slides at a time, right? So I could actually pace you to, I can restrict you if I want to. That's what pacing allows to do. But I won't do that for time's sake. I could also anonymize the names. Many times when you're showing student work, students might get embarrassed if they have an incorrect response that the teacher is displaying. I love to have my students analyze each other's work. And when I display the responses and what they think about something, I make their names anonymous. Desmos gives them mathematician names, right? You recognize any of those? right? It's pretty cool. So you can hide student names at any time by pressing anonymize. Okay. You could take snapshots. Again, the sky's the limit there. But if you could you all go to screen 3? You could try that marble slide there. See if you can knock those stars down like we did before. Okay. I know we have 3 minutes left before questions and answers. I want to be mindful of time. But Desmos is fun. When they say their mission is to get students to love math and love learning math, they do that job very well. And the teachers that teach math using Desmos love it. They really do. And with Desmos, you can do so much. Like that turtle example that the team built, there are advanced features of Desmos called computation layer that you could learn. And if you want to take stuff like this to the next level, you totally could. If you go to screen 4, see, I could see some, if you look at, remember the card sort we did right there? That was the card sort we built. One student's in progress. One student did not do it correctly. And I could see which students have started it. Someone got a marble slides correct, right?
Yeah.
It's a quick summary of where students are and what they are doing. Okay. So, but there's so much you could do with Desmos. I love using it. And so I will continue to use it as I continue teaching high school mathematics next year in a new district. So, but going back to the slides there on the very last page, if you like these ideas, I post a lot of ideas for teaching and learning there. It's on the very last page. I'm on Facebook, Twitter, Instagram, YouTube. You can find it there. Ideas for teaching and learning, because I absolutely love engaging students, and I love apps like Desmos that help teachers do that well. So thank you very much for your attention, for having me, and I'll leave it for questions and answers.
Yeah, thank you very much, Tim. I think it's been very amazing, using this. It's kind of very useful. I mean, like very powerful tools for the mathematics teachers to use. I think we've got some questions here, in both quick Q&A box and also in the chat box as well. I would like to start with the first one from the Zoom chat box, I think.
Yes.
It's something that I think not only me, but not only them. I mean, like if this question comes from C. Devi Muyanikati. Correct me if I'm wrong, sorry. She asked it, how effective Desmos for smartphone, because where she lives at a village and most of her students don't have PC or laptop. I think it's quite the same problem, with many countries that
Yes.
they have only like smartphone and kind of very small one, but they don't have the PC or the laptop or even the, iPad or tablet to use. So with kind of effective for them to use.
I have used Desmos. I have had students forget to bring their Chromebook to school. So you never forget your phone. So get your phone out. Well, in my so I said, listen, use your phone. I actually would have them use their phone. Now, some Desmos, they're like, if you have a card sort with like 20 cards on it, that's going to be hard to do on a phone, right? And you'll get, Desmos will give you a large screen warning and it'll kind of warn you, you sure you want to go ahead? But there have been some activities I've been able to do with students who don't have the computer. They've done it on their mobile phone and with much success. So you can access it through the web on a phone. Absolutely.
Okay, right.
Yes. Can I answer I see some questions in the Zoom chat. Can I answer a couple?
Yes, please.
Adding a co-teacher for teachers that team teach together. I forgot to show that. That can be done right here. Say for this this activity that we're currently in now. If I go here, if I go to shared, if I go right here to share dashboard. So you click on the title of the activity up top. You could share the dashboard. I go here and I type the email of my colleague. That way, when he or she gets the link, the link for the dashboard, they will be able to open it, but everybody else in the world will not be able to. So that's how so that answers that question.
right.
there. And
Okay.
so one person asked, are students able to have interaction with other students to solve certain math problems in Desmos? Yes, they can. I think we're all used to doing, the platform being Desmos to do that. Polygraph, I didn't show you Polygraph, maybe with time after. Polygraph is the one case I could think of where you can, but we use Zoom, we use Google Meet, we use a lot of things. So we have phones, I think communicating with each other as teachers and students, I think we've solved that problem. But what Desmos says, I want to answer one particular thing with feedback. Okay. In terms of giving students feedback, like I could go to, let me click on, I could say, go to say now actually, say the student who's disguised as Martin Gardner, I could go here, for example, and there's a little icon right here, lesson feedback. On any screen, I can provide written feedback to the student, and I could say, whoa, what happens when the graph gets more vertical, or something like that. And I can actually I just sent one comment to one student in a class of a few hundred, right? And that student, whoever he or she is, if they look at the top of their, they'll see a little notification, they'll get it. I have had students work independently, like students are in different spots, and I would just say, hey, watch your sign or watch your. I'm just typing short comments, and I can actually monitor that. I can actually give feedback faster in certain cases by typing it fast versus walking around and looking like on physical paper.
Right.
But it's pretty cool. Right. But let me go back to the screen there. What topics in primary school can be used using Desmos? That is a great question. I know Desmos has expressed an interest in creating curricular activities for those grades. I know I feel bad because middle and high school math teachers, they get like, oh, there's so much stuff, and primary teachers feel like we feel left out, and it's hard. If you do a Google search, you will find things. Okay. And even another cool place to go, Desmos has a Facebook group called Desmos Educators. Right. It has like, I think 16 or 18,000 people in it. They ask questions, they support each other, they help each other. And somewhere in that group, somebody created a huge Google sheet full of like thousands of activities people have created, which is pretty cool. But if I can find that before the top of the hour, I'll try to get that for you because it's an amazing sheet. So the answer to that will be there. What other questions did you have?
Okay, I've got a question, a person that would like to ask you directly. I will invite her to come up. It's Miss Adinda Camila. She's got some questions at the very beginning of your session, and I think it's quite interesting. Please, okay. Miss Adinda Camila. Let me find her. Miss Adinda, are you here with us? Perhaps not. I think. Okay.
Good morning.
Okay.
Hello.
Hello.
Hello, Mr. Tim. It is very nice presentation of you.
Yeah.
Thank you.
And this is quite interesting and fun. But I would like to know. I would like to know how do we measure the improvement of students, specifically using this Desmos. Yes, Desmos. I mean,
well, go ahead.
I mean,
while using Desmos, how the teachers measure the student improvement during
Yes.
they're doing the practical on Desmos, right? Okay.
Well, I think it's a matter of, when we look at improvement, I mean, are we looking at raw data scores? Like, because again, with COVID-19 and the unfortunate effects and it's placed on societies everywhere, right? We have to totally rethink assessment, period. We have what we call formative assessment, right? And summative assessment. Now, summative assessment is that end of chapter, end of the course exam, right? Every books away, pencils out, calculate, it's like, show me what you know, what do you remember? But but with COVID-19, we can't do that, right? And people at home here. So we have to rethink assessment and what defines improvement altogether. Now here, if on the screen that I'm sharing right now, if I ask you as a student in my class to sketch a function where that has the turtle walking from the grass to the water, but I want him to stop. I want him to stop for 4 seconds along, it's somewhere in the journey and speed up. Say I give you problem characteristics, that is your assessment now. But see, you have the opportunity to test it out again and again and again. Like I could try it here, right? Oh gosh, oh wait, no, the turtle's going up. See, I can learn from that and do that. So, it almost like replaces the need for, it's like, if students can actually build it, then when things get back to normal, when it comes to the high stakes exams, they know it conceptually better than students who just sit in a classroom, listen to a teacher lecture all day and take notes. And, algebra teachers could testify that, when you ask a student to find the slope of a line, they give you the equation. Or when you ask them for an equation, they give you the slope, or they plot an ordered pair. So no real learning really took place there anyway. So with activities like these, the assessment really needs to be built within the lessons, as I know many of you agree that they need to. But I think in terms of measuring improvement in the long run, right? It's for the better. I don't have quantitative data at the moment, but I know Desmos does have a research team. They test these activities, they curate them, they make them better year after year. And if you look at their website, on the curriculum site, they actually have studies that have tested the effectiveness of students, pilot districts who are engaged in that. And you could read the literature. It's all on Desmos' site.
All right. Okay.
Well, thank you.
Very much.
You're welcome.
Thank you very much. And the last question, I think from the YouTube, I think you've been mentioned about this already, because Marisha from Bandung, Indonesia asked, can Desmos be integrated directly into Google Workspace for education, for example, to Google Classroom?
Yes.
I think already mentioned.
I do that. I honestly, I have to plan something for tomorrow, so I could do it right now. I could show you how I do it. But let me just go to, hope this doesn't do the bandwidth too much, but let me go here. Sorry for my messy desktop. I'll go to my school account here. But watch this. If I go to I have two Google accounts here I'm using, but this is my school account that I'm using right now. So what I do is let's say I want to find an activity. I'll just pick this one. I'll just do marble slides. Parabola, say. All right. Let's pretend I'm going to use it as it is. Oh, by the way, one thing I'd say, if you want to copy an activity, remember we copied screens before, but if you want to copy the entire activity, you go up here and look at that. You copy and edit it. You could take stuff out. You could put new stuff in. You could edit it to your heart's content. And what Desmos will do is they will attribute, it'll have my name on it and it'll say, it was edited by me, but the original author was Desmos, right? So I copy and edit it, but here's how I do it. I assign to my classes. If you click this, these are all the Google Classroom classes that I have or I'm in. So I could assign it to any one or more, right? And I have preferences. I could post it as a draft because I don't want students to see stuff right away, or I could post it immediately, right? That kind of thing. But right here, let me just go, I'll just post it to one class just to show you, right? Now you have to initially sync up Google Classroom. If you go to the classes part, it's very easy. If you Google it, you'll find it in a second. It's so easy, right? I sign it there, and now I hit assign. And now if I go to Google Classroom, check it out. Should be there. I forgot, I think I have too many of them, but I get this one here. Classwork. See, it's right there. That's the one I just did, right? And so you could check as many classes as you want. And Desmos, the way that Desmos syncs up to your Google Classroom classes, it's a beautiful, painless integration. It is like, it's the most user-friendly. It really is.
Very nice and easy. Yeah, very nice indeed. I think the time is up for the Q&A session, but I think the remaining questions can be, like leave here. And if we can answer that, we will. But if not, if you don't get answer right away, please feel free to leave it on the CTeam webpage or I mean, maybe your team, your Facebook or your website as well, right? They can like contact you as well. And thank you all for the questions, kind of very interesting. And it has been very good morning, to listen to Tim and to kind of practice along with him as well. And we know technology can do many, the sky is the limit now. I hope that all the teachers will have an idea what to do with the next class of them. And thank you, Tim. Thank you, Mr. Brzezinski, for sharing with us today. And I would like to extend my sincere gratitude to Kim as well for organizing this very useful seminar. And I hope you all enjoy the morning. And thank you. Back to you, Lily.
Thank you very much. Thank you. It was a pleasure, an honor.
Thank you very much, ladies and gentlemen. Please give a round big applause to Mr. Tim Brzezinski and also Dr. Nutapurn. Thank you very much, Mr. Tim Brzezinski, for the insightful presentations about Desmos. And sure, thank you so much for your effort also to share your expertise in our different time zone. And it's time for you to sleep, Mr. Tim? Okay, thank you.
Okay. Thank you.
Yes, and Dr. Nutapurn, thank you so much once again for leading the first keynote address very professionally, and hope we can have more collaborations ahead. Thank you so much.
Thank you.
Well, ladies and gentlemen, that was the first keynote address. We will continue to the second keynote address. Together, we will hear the presentations of Professor Zot Lufixa from Johannes Kepler University of Linz, Austria. And his sessions will be led by the moderator. He is Mr. Imam Fitri Rahmadi from Pamulang University, Indonesia. Allow me to read the short biography of our second moderator. He is Mr. Imam Fitri Rahmadi, a lecturer at Pamulang University of Indonesia and currently a PhD student as well as a researcher at the Department of STEM Education, Linz School of Education, Johannes Kepler University, Linz, Austria. Educational technology integration into learning and instruction is his overall research interest. His PhD project explores the potentials of user-generated microgames for supporting STEM learning. Good morning, Mr. Imam. Are you here with us?
Good morning. Good morning.
Thank you, and I hand over the platform to you.
All right, thank you very much. Good morning, everyone. We are here. I am speaking in Linz, speaking from Linz, Austria, and here still at 5 in the early morning. But thank you very much, everyone, for inviting us. Also, thank you very much, Prof. Lufixa, for your time. I saw you are already here. Good morning, Prof. Lufixa.
Good morning.
Oh, great. And before we start, I would like to introduce you with Professor Zot Lufixa from Johannes Kepler University, Linz, Austria. He is a university professor in STEM education research, methods, at the Department of STEM Education, Linz School of Education, Johannes Kepler University, Linz, Austria. He has worked on several research projects examining technology and mathematics teachings in classroom environments. and he has greatly contributed to the development of the GeoGebra community. And I have to mention that Professor Lufixa is my PhD supervisor here in JKU Linz. He is the best supervisor, one of the best supervisor in the world, I believe. And I think this session will be divided into two parts. The first part is the 40 minutes for presentation, and this will be followed with 20 minutes for questions and answers. And now I will hand the next 40 minutes for Professor Lufixa. I believe he will talk about technological innovations that we did here in Linz. And then the floor is yours, Professor Lufixa.
Hello, good morning, and thank you very much, Imam, and hello, Tim. It's very nice to see you, at least virtually. And Imam, thank you very much for this very nice introduction, and I'm very happy to work with you because Imam is one of my best PhD students among the many PhD students. So I'm very proud of him. He's doing really excellent work, and then it's really great to have such good students from Indonesia, and then hopefully in the future we will have more collaboration and more such good students from Indonesia. So thank you for the invitation. I share my screen. I hope it works. And does it work? Imam,
yes,
is it okay?
Yes. Perfect.
Okay, so I talked with the Imam about the presentation, and so in the past I gave a similar presentation. I just added some new information about what we are doing here in Linz. And as Imam said, that we are working on STEAM education. So I'm leading the doctoral school on STEAM education, and we are doing lots of development with technologies, and essentially all of our work is involve the use of different kind of technologies, especially now GeoGebra, and I will introduce you what is the use, or what is the development of GeoGebra, and then also I give you some introduction of the technologies that we are working on in relation to STEAM education, because then that is then the main focus of our work. So and let me just start with the introduction. So I'm leading the doctoral school in Linz, and we are working on many interesting topics. And then this is where Imam is contributing to our work. So I have more than 40 PhD students working on many interesting topics. And we are using technology to the improvement of education through STEAM. And STEAM is then the STEM subjects and arts, but we use arts more like the development of creativity and creation and innovation as well. And it's a very integral part to use technology for this. So we are working on this kind of research topics and try to integrate technology wherever is possible. And then we are also very fortunate to work with the team of GeoGebra, especially Professor Markus Hohenwarter, who is leading the team on GeoGebra, and then he is also the designer and inventor of GeoGebra. And then many of you probably already know GeoGebra. It became a more integrated software of mathematics and then other subjects as well. So I give you some updates about what we are working on, and then there are lots of users around GeoGebra. So this is a huge community, and then working on with millions of users around the world, and it's used from primary to university level. Of course, it's one of the software which is being used in education, but since our team in Linz is based next to the GeoGebra development team, we are working with GeoGebra to enhance the software, and then also doing research in connection with the software as well. So what is good with GeoGebra, that has a large community, and also contributes to many of the topic development. So there are millions of materials available for GeoGebra in the GeoGebra materials website, and then we also try to booster the community with the GeoGebra institutes, and then that is aiming to support this work about what we are doing. So I will give you some updates of what are the new technologies, and then also the research related to these technologies. And then also we have lots of collaboration in Indonesia, and Imam is leading this team, and then we are hopefully we'll be able to contribute more to these communities. So as I mentioned, in STEAM education, we are using lots of technologies, and then we are trying to use the creativity and innovation side of these technologies. So then there are many different ways to be able to look at creativity. So creativity is an integral part of our work, and why creativity is important, because if we are looking to the future, the content is more and more available on the web, and then also it's shared with a large number of resources around us. And then what we need to do in schools is to boost the students' creativity, and then also the innovation side of students to be able to contribute to the new developments of the society, and then also the workforce, because technology and machine learning is taking all on the road learning on the road activities in the society, and then we need to create creativities in education, or nurture the creativities in education to be able to contribute to the society. So what we are trying to do in Linz is trying to do research on these kind of technologies in connection to pedagogies, policies, and the environments to be able to create possibilities for boosting creativities in education. So how we are doing this is based on the development of technologies, and then also the development of different pedagogical approaches. So what we try to do is that developing GeoGebra as a software for all different environments. So now it's mostly used on tablets and mobile phones, and try to create a new interface that is helping the the use of or the applications of mathematics in this kind of environment, and then we are creating these interfaces for the users to be able to use this. So we have GeoGebra books, which is a way to create a collection of materials for students. And there are already thousands of GeoGebra books available. And we are creating these GeoGebra books for each student or teachers, or either a collection of interesting materials that then that could capture a different topic. So I recommend you to look at these resources and then also create your own books or collections to be able to use it. And then also we try to create new collaborative environments. So the GeoGebra classroom is an online environment where the teachers can create a space for students, a virtual classroom, to assign problems for the students, and then we'll be able to monitor what the students is doing. So it's very similar to, for example, Desmos or some other online environments, but it's just another way to simplify the learning environment, and then to be able to follow students' work in this environment. Same with in this GeoGebra groups, so you can create groups to work together with students and then integrate into the GeoGebra or some other learning environments as well. So what we also try to do, and then it's under development, to connect the different sensors of the mobile devices, and then use these sensor data to be able to use in the classroom, so students can collect user data, or collect data from their environment, from the different sensors, and then use it in this with this way as well. So there is an application which is allowing students to take exams. So I think Tim was working on this for a while to take exams, and then also now there is a new interface we just released in the past week, is the GeoGebra Suite. So now there is a new interface of GeoGebra if you update your software to use this interface, and then hopefully this interface will contribute to your work. So then there are many GeoGebra apps available now from the App Store, both on Android and Apple. And the GeoGebra Suite is integrating many of the elements, but also there is a simplified app features for different purposes in education. But now with the new GeoGebra Suite environment, what we try to do is more customizable ways to the different levels of education, and then also for the teachers in these classes to be able to choose the right kind of topics, and then also the features then that you are using in the environment as well. And a very important part of the work what we are doing now is augmented reality, and the team is doing lots of work, and then also now many of my PhD students are working on the augmented reality environment. So this is Ben from Luxembourg, who is doing work. But if you look at Tim's videos, he's doing lots of very interesting applications and modeling of the real world around you. So then there is really amazing materials available on YouTube and then on different sites. Then I really recommend the work of Tim to see this. And then also what you can do, you can just have mathematical objects placed in the environment and explore it. But then there are many different ways. And then I will show you later that we are combining this augmented reality with different games and then also with different apps. And then using, for example, MadCity maps to have outdoor experiences with GeoGebra and augmented reality. And the other part in which I talked about it in other conferences in Indonesia is 3D printing, that how we can connect 3D printing and augmented reality and GeoGebra in this work. So last week we had a conference and we were talking a lot on 3D printing. And we are doing lots of modeling. So this is one of the 3D printing startup in what we are working on to be able to create an educational 3D printer. So many times then the 3D printers are created for manufacturing. But what we try to do to be able to help the teachers to be able to set up and the printers and also simplify the 3D printing environment as well. So then this is the workshop in Linz. So my PhD students or ex-PhD students, Diego, created lots of 3D printing materials. I will show you some more. And then also what is very important to integrate this creativity and innovation to work with artists and look at the environments that whole this kind of mathematics and STEAM could be connected with the arts and creations. And then we also try to look at machine learning, that whole to connect the data flow with GeoGebra, and then how to detect creativity. And also based on this usability research, what we are doing here, so the new GeoGebra suite then was tested in new approaches, but also what we try to do to combine research methodologies like education research and user experience research. And two of my PhD students is using on this kind of new methodological approaches for education, which will be highly important for researching technologies in education. Because many times when we are working in our team, we use design-based research. But what we experience is that the pace of design-based research, I think many of you know design-based research, which is connected in cycles of newly designed environments, and then developing these new cycles in these environments to test and then applied in the new environments. So in that case, we can use the design-based research, but many times what we find that by the end of the research cycle, the technology is improving so much that it's very difficult to integrate the new cycles without updating the technology and technological approaches. So now we are trying to come up with new educational research ways to keep up with the fastly or quickly updating technologies. So based on this, we are working on environment. So for example, GeoGebra Notes is an environment for students to create portfolios. And then also what we try to do is to create maps of concepts to offer teachers or students the right kind of materials, or at least offer a selection of materials within GeoGebra to use in these materials as well. So indeed, these are some of the technological innovation, but it's very much connected to pedagogies, because with technologies, it's really important to integrate the technologies with pedagogies. So what we try to do is trying to find out the misconceptions in the new digital environments. So students learn very differently in the new digital environments, and then we try to look at that what is changing in these digital environments, and we are writing lots of papers in connection to these new technologies and new environments. A very important part of this is the increased use of gamification. So we are working on many different projects to be able to gamify the environment and then create a gamification editor. Imam is also working in a new project called Steambox, which is funded by the European Union. And then we are trying to create a new gamified platform for teachers and students. And I think many of you already received and then filled out our questionnaire that how we can contribute to our gamified environment. And then maybe Imam can contact you as well on this. We look at, for example, flipped classroom and inquiry-based learning. So my students and postdocs or colleagues are working on the flipped classroom environments, which is a very important way to be able to integrate technology into the classroom. A very interesting way in which I think many of you are familiar who were participating in some of the lessons is connecting physical and digital environments, especially using the new technologies, 3D printing, augmented reality, 3D scanning, and then this digital transformation in education. So I think recently Shireen gave some work. So she's a student from Egypt working on architecture and then the development of different materials. So last week we were trying to see that how then the physical and digital world could be connected with culture, history, and architecture. So what we try to do in this research to create an environment where teachers can choose the different technologies and then the different physical resources like 3D printing materials, origamis, and 4D frames. They're the place where they want to work in this environment, in the classroom or at home or outdoor mathematics, and then also the level of children. So what we try to do is create an interface where teachers can find the way how they could use maybe this kind of modeling, and then we are trying to connect these environments with the technology and then also the needs of the teachers as well. And I think Shireen is working in Egypt, but she is also working on different architectures from all around the world. And I know that she's working with many teachers and students from Indonesia. So this is a European way to look at things. And then also we are trying to look at modern architecture as well, to be able to do this modeling and then connecting culture, history, and education as well. So very similarly to Sherin's work, we try to look at outdoor mathematics. And this is what I try to explain, that we can go outside of the classroom. And Ben in Luxembourg is working on this idea, but also you have a great researcher, Adi Noor, in Indonesia, who is working in MadCity maps and creating amazing maps in Indonesia and then using GeoGebra. So I think he is a good representative in Indonesia or Asia to use this. And then we can use again different technologies like AR and 3D printing in the outdoors as well. So all to this connection, Kyung Choi from South Korea, who is coming as a postdoc later to work with us, looking at architectures in Korea, and then also my colleague who was also speaking on different things from Israel, looking at the different cultures and integrations of these cultures into education. As I talked about this in the past as well, about integrating games into education and then connecting it with different technologies. So we try to look at this physical and digital connection of technology, and looking at the technology that allows these connections. So we are creating lots of different kinds of games. So I think some of you, maybe I can share some of the videos on what we created last week. We were looking at 3D printing, laser cutting, and other technologies to create games. And there are hundreds of games are being developed with my colleagues in Brazil and then also in Linz. So we are adopting existing games like the Quattro game for the school. So both teachers and then also students are creating these games in the classroom, and then we are using the adaptation of games for different new environments using technology, either only digitally or we can take it to the physical space in this kind of game design. So our goal is to create a new era of manipulatives. So now technologies allows us to create both physical and digital environments, and then we can create in this kind of new manipulatives for education as well. So then there are lots of possibilities, and then we can share you with all of these links, and then you can create in your own classroom. Even if you don't have a 3D printer yet, it's becoming a very affordable in the future. And then even using a mobile phone could do some modeling and scanning, and then it is possible to use in this kind of new technology environment for these creations. And then soon this kind of 3D printing environments will be available, and then you will be able to utilize it as well. So another part is that we are trying to look at these games at these games imported into the classroom. So we try to look at technology from a broader perspective. The technology could be digital technology, but it could be technologies not only digitally, but also some of the manufacturing environments. So then that's why we try to look at 3D printing, laser cutting, and other manufacturing work. So these are the great students who are working on different projects. And then we are creating these games within different manufacturing. So in Linz, now we are creating a new STEAM education lab to utilize these games, utilized in this environment to connect the physical and digital resources as well. And of course, you can create, for example, cookie cutters, and then you can bake together with students and then work on this as well. And then we try to also teach basic designs of 3D printing for students, so we can create our students can build their own 3D printers and then learn the materials. And then, of course, Imam is here working on micro games, and I highly recommend you to look at Imam's work on user-generated micro games, because these are just short games then that could be integrated into everyday classroom practices, and in these games motivating the students and then using this new approach to teach different concepts. So I think Imam has a large connection of micro games, and then you can use it, and then I think it's a good way to look at technology from a game perspective and then integrate it into different environments. So then there are many other ways we can use technologies and then connect technologies to the physical world, and also to computational thinking or computer programming. So we work a lot with origami, which is a very accessible kind of paper technology, but it can be connected to mathematics and computer science as well. We try to look at technology also from a different perspective, like videos. So students are many times used, or then in this kind of videos are the integral part of students' lives. So, for example, Bea, my other PhD student, is looking at short videos, but I have Clara, another student, who is looking at YouTubers. That how we can bring student culture and technological environments into the classroom. Same with the mathematical memes. So my other student, Julia, who just finished her PhD last week, looking at the mathematical memes as a technology or a media creation to use this kind of new technology into the classroom. So it's very interesting research on memes and cartoons and videos that we can use in this new digital era. And also what technology allows us, that looking at, for example, music and mathematics from a different perspective. So Lajos is designing a new app with music, and then we are integrating this together with GeoGebra, so students can learn music and mathematics together, and then used in this technological environment to connect the different subjects, and then also making interesting ways to look at. And then also we can use technology for sustainable development. We can connect mathematics and statistics, and we are using world data to model the sustainable development of different countries and cities as well. But we shouldn't forget on students' well-being. So Yuka, my new student, is coming to Linz. So he's using these Finnish classrooms which he's designing, and then also using some smart devices like these bracelets to measure the stress level and the well-being of students. So we are collecting data from students that how we can create a favorable classroom environment where students have less stress, but also that enhancing their lives. So we are collecting lots of these sensor data from students to do this. And then also my colleagues in Argentina and Uruguay is looking at how we can use digital photos to introduce mathematics, and then you can take lots of photos, and then there is a big competition in Argentina, and then also do this modeling with GeoGebra as well. We look at assessment. So last week we had a conference and with policymakers and then the Ministry of Education, and then also next year we are organizing a large conference that whole technologies could be integrated into STEAM education, but I think it would be a topic for a different topic. So STEAM education for us is really an integral part, but we are using technology in all different ways to make the STEAM education possible. So we are working on lots of projects. So these are the nine projects that we are running, and I have a really great team. Imam is one of the members, so he's working on the STEAM box and the STEAM Teach project. But we are trying to look at that how we can integrate STEAM education and technology. And then also we are working with Christoph Fenyvesi, who many of you know from experience workshop to booster the STEAM education, and then trying to create amazing events. So last week we just had a big conference as well, and then we are hosting many events. So this was our conference last week, but also in some weeks we will have a new Catch Me conference, which is digital tools in mathematics education. So I encourage you to participate in these events. And then also we have hundreds of papers available about this. And then this is a great news, because 2 weeks ago we just moved to this new building, and we have our new offices, and then soon we are developing a STEAM education center to make this technology integration more possible. And then also we have a group on Facebook which called GeoGebra Arts and STEAM. And this group is growing very fast, and then we are sharing lots of very interesting materials on STEAM education and technology. So I encourage you to join this group in Facebook. And then, of course, we are very happy to collaborate. We already have lots of collaboration in all over the world. Also in Indonesia and in Asia. So we are very happy to host PhD students, colleagues, and then also share our vision and experiences. So I think then there are some updates on technologies. and I'm very happy to answer questions, and then more having a discussion. So I try to make this presentation as just as an introduction and reflecting on the technologies. And I hope I could contribute some new ideas, but also we are working on many new projects and ideas, and then hopefully next time I will be able to share other interesting topics as well. So thank you very much, and please just ask questions or whatever is interesting for you, and then maybe something which I didn't cover. So thank you. And Imam, is it okay?
Okay. All right. Thank you very much for your very interesting presentations. Exactly 40 minutes. Really on time.
Good.
And there are some greetings on the chat. I may read it from Erwin John Santos. Good morning, Prof. Lufixa. Greeting from Manila, Philippines.
Oh,
and
nice.
Also from Dr. Farida Nur Hasana. Hello, Prof. Lufixa. Nice to meet you virtually here.
And hopefully you meet not only virtually here. So I think
sure.
Then hopefully there will be opportunities to work together in the future.
And the next comment is coming from Wutichai Budi. Good morning, professors. Nice to meet you. And also,
hello.
Erwin John Santos also commented that creativity is one of the forces of 21st century learning.
Yes, definitely. I think we really need to move from content to creativity, because content is available, and what we need to do is things which the machines cannot do. So I think it's very, very important for us to look at new ideas and then be brave to explore new ways in education, because AI and also robots will be able to do many things, but the creativity is very difficult to mimic for technologies.
Okay, thank you very much for your response. And now let's move to the second part of these sessions. For the question for keynote speaker 2, Professor Lufixa, as mentioned before by the Master of Ceremony, there are three sources of question. I will select, I think, the most relevant questions. One question from Zoom, one question from Slido, and then the last question is a live interaction question from Zoom participant. But I think if the time we still have time, we can continue to the second or to the third live interaction questions. Let's start with the first one. Prof. Lufixa, can you see my screen, by the way?
Mm-hmm.
Yes, and the question is coming from Virastuti asking about, is there any specific app to combine GeoGebra with augmented reality?
Yes, so GeoGebra is combined with augmented reality. So if you download the GeoGebra 3D app or the GeoGebra suite, it's already integrated with augmented reality. You just need to tap on it. And then also there is, I think on Android, you need to install some kind of AR connection, but I'm not sure. But if you go to the GeoGebra site, then it's everything explained. So you can already start using GeoGebra AR if you download the app. Yeah. So.
Okay. Yeah.
Mm-hmm.
Yeah. Please go ahead, Prof. Lufixa.
Yeah. So just download the GeoGebra 3D app, and then it's already integrated with technology.
Okay, thank you very much for your answer. Hopefully, it's answer your question, Ms. Virastuti. And then the next question should be from Slido, but there is no question there yet. So let's go back to question from Zoom. It is coming from Berti Hajati, and the question is it possible to the computational thinking without computer? Maybe is it possible to develop computational thinking skill without computer? Thank you.
Yes, then definitely. And so, for example, music is a very good way to develop computational thinking. And then also we use origami. I just shown an example when we are using origami to create a dragon curve. I don't know if you know the dragon curve. And then that is a kind of algorithmic thinking. But also now we have a new project called Colette. And then also we have colleagues in our team, CoolLab, who are developing different activities. So we use, for example, dancing and music, and also many other kind of activities to develop computational thinking. And it's not really necessary to have a computer, because many times then the decisions and the algorithms, what is needed for the development of computational thinking can be done with other tools, and then also just by using even traditional methods to develop these too.
Okay, so it is not always should be used or connected with computer, even it is about computational thinking, isn't it?
Yeah. Then definitely, and then there are lots of activities. So computational thinking is more like understanding the algorithms and the procedures, and then it could be done in many different ways. So, for example, music and dancing or origami is a very good way to introduce and then also motivate computational thinking.
Okay, I hope it's clear enough for the questions. And then next move to the very challenging part, very interesting part for live interaction questions. I saw someone raise hand on the Zoom. She is Ma Teresa Dinong. Could you please open your microphone to ask your questions? And I will stop sharing my screen. Hello, Ma Teresa Dinong, are you there? Okay, you can unmute yourself, I believe.
Sorry, sir, I don't have a question. I just accidentally clicked it.
Sorry?
I don't have a question, sir. I'm very sorry. I just accidentally clicked it.
No problem. Anyone else want to ask questions or just say some things commenting on Professor Lufixa presentation? Please raise your hand or just open your mic now. If there is no one, I would like to, oh, yes. Okay, please.
I would just like to thank the professor very much for that wonderful presentation. You covered so much, so it was delightful to watch. Because we had the Desmos first, for me, the issue is teachers invest time, whether it's with GeoGebra or Desmos, they invest time. And then it's a matter of, you know, do you have to pay to get the extra features? Now, that's the difference that I find myself, that I tend to push people to GeoGebra rather than the commercial side of things. So I don't know whether you would like to comment on that, but anyway, thank you very much for a wonderful presentation.
Yes, thank you. So GeoGebra, so we are open source in GeoGebra, and then and essentially we have a kind of basic constitution or something that GeoGebra will become, will remain always free for teachers and for students. So it's not possible to change. So it will remain free all the time. And then we are also mostly community based. So we encourage the community to help developing GeoGebra and then also creating the materials and sharing. So then that is the price you pay. That if there is something interesting that you create, that please share it, because then that is the value on what we are developing. But of course, then there is a place. So digital education is just growing, and then there are different ways to have a commercial thing. So if you look at in the past year, the educational technology space just boomed enormously, and then also there are commercial partners, which are, some of them are really good, but some of them are just really trying to make money. So from the GeoGebra perspective, we tried. We are remaining more of this open source academic and then the community based work, and then we try to offer what is available and then what is possible, and then if it's enough for people or if they like it, then they should use this kind of work. And then my work is really to do research, to open up new possibilities, and then that's what I showed. And we are really open for this point of view. So, and then this is our approach. And then, of course, we acknowledge that there are some other approaches as well.
Thank you very much. Yes, I think that, you know, if when young teachers come to me and ask me, should I do this or that, I've always pushed them to GeoGebra because of the many aspects that you showed in your presentation. So thanks again.
Thank you very much. Very appreciate. And then we are very happy to collaborate and work with any of the teachers or researchers. So thank you.
Thank you, Alan, for your questions and comments. Maybe we can keep in touch in the future. Okay, for the next question, I will let someone ask question directly. Please open your mic. Is Yulia Suchi? Yes, Yulia Suchi, you are permitted to ask your questions.
Yes, hello.
Hello.
Yes.
Okay. I think I cannot open the camera. I don't know why. I think the host locked me.
Okay, no problem. Go ahead. Yes.
Okay. Hello, Professor. Good morning.
Good morning.
Yes, I'm Yulia. I'm a teacher of primary school. And I'm so interested about your presentation about GeoGebra, about STEM. And I really want to use that one with my students. But, you know, I'm still thinking and keep reading about how to implement the STEM to the young learner for primary school, you know, from 6 to 12 years old. And then as I saw the presentation from you, we can use also origami paper, right?
Yes.
But is there any kind of example that can give me more idea about how to implement STEM? And then either is it using the technology or not using the technology? Because, you know, I trying to using the GeoGebra to my students, and then the problem is their mobile phone is not supported, and it's only less students that have a laptop. So that's the issue. So I hope that I can get more idea from you, Professor. Thank you.
Yeah. So I think GeoGebra is supported in most mobile phones. So I think you can use mobile phones. So most of the uses of GeoGebra is now on mobile phones. And then also, if you go to the GeoGebra materials website, you will find lots of tutorials and lots of very interesting examples. Same with origami. And then you can use origami. So if you search on the GeoGebra materials, like origami, you will find lots of examples. And then also, if you are interested, you can send me an email, and then we can send you some papers on origami or the use of GeoGebra. And I'm sure Imam already have my publications, so he can share the thing. So essentially, what you can do is that if you go to the GeoGebra website and then use the materials, you will find all the tutorials for origami, for 3D printing, for AR, for calculators, for tablets, and so on. So just go there, and then you will find many ideas, and then that could be suitable for your students. So what we try to do, we put all of the things in which is available for teachers, and then you can just choose one what is the best for you. So I think if you start to look, then you will find many materials which is which will be possible.
Okay, and maybe yes.
I think I can email Mas Imam, yeah. Mas.
Yeah.
From Unpam, right? So close with me.
Yes, thank you very much. Yes, I am a lecturer at Universitas Pamulang. And maybe I can add something. If you find difficulties to use GeoGebra, feel free to contact the GeoGebra community team. You can find out the email on the GeoGebra. I believe they will answer everything that you ask to them.
Thank you. Thank you so much. Thank you for the information.
Thank you.
Okay.
And then of course, Imam knows everything, so he's my representative there. So.
And I found a very interesting comment on the chat from Nur Hasmalina. I have interesting experience using GeoGebra when I'm writing books about basic algebra for my students. I feel more easier to make graphics on the GeoGebra applications.
Excellent. So very good.
Okay.
So just please share what you make, and then I think it will be good for everyone. So good.
All right. And please let me invite one more question from audience. One participant raised hand from Adinda Kamila. You are permitted to talk. Could you please just unmute yourself and ask your questions?
Thank you for the opportunity, Mr. Su.
Hello.
Yeah.
Yes.
It is very various and useful innovation of mathematics learning you have presented before. It is very interesting for me. And I would like to know, what do you think? Do you think that those activities and games can be the main math learning focus, or is it just some tools to engage the students to the learning activity? I mean, like the example is like searching for pattern and orders in environmental shapes. Can it be the main focus for the math learning, or just some tools to engage them to make them active?
I think games are very important. And then also, so I think what we consider now education, the students have to take it seriously and work on examples. But I think if we create activities where the students don't even recognize that they learn, I think that is the best way to engage them. So for example, Imam's microgames, they are just playing it, and then they don't even recognize that they learn mathematics on the way. But of course, there's a side effect. They learn it and then they perform it in the exams. And then also our work on YouTubers, that if we give students some word problems in schools, they hate it and then they don't want to do it. But then there are some YouTube channels which is explaining games with mathematics and then calculating the ideas on different game elements, that what is the weight of something like this. And these YouTubers have 10 million followers and millions of views, and exactly the same kind of problems as we do in mathematics in the classroom. But they don't want to do it in the classroom, but millions of students are watching YouTube to learn the same kind of mathematics. So I think what we need to do is then have a different perspective on education, that engaging the students, and then even maybe the students don't even recognize that they are learning, because we need to compete with the current environments what they are engaged every day. And then these kind of games and these kind of activities that I try to show you is creating these possibilities for learning. So I think, yes, definitely, I think we should make this work. And then I think Imam can share his microgame collection, really amazing. And then you can try, and then you will see that it's a good possibility for learning and in different ways.
Okay, thank you very much, Prof. Lufixa. Unfortunately, I think this session is over, but there are still some questions on the chat. I will try to answer after I close this session. So to conclude, could you please give us closing remarks, Prof. Lufixa?
Yeah, so just be creative. So I think that is very important. Not only creativity in learning, but also creativity in teaching. So try to explore, try to do new methods and then be part of the community, learn from each other, because I think now we have so many tools and then so many opportunities then that is available all the time. But what we need to do is just take advantage of this. And there is so many things is available. So I think it's not a question of resources, but it's just more the courage of you to try. So be brave and creative. So
all right, well known. Okay, thank you very much. And I would like to hand back this Zoom to Ms. Puspita once again. Thank you very much, Prof. Lufixa. And
thank you. Thanks a lot,
thank you
Imam.
very much for inviting us.
Yeah, thanks a lot, Imam. You are always great. So.
You're welcome.
Thank you very much, Mr. Imam, for leading the second session. Please give a round of applause to Professor Lufixa and Mr. Imam. And Sikim feels honored to meet the best PhD supervisor and the best PhD student of Lin School of Education. Yes, hope to see and collaborate with you in other Sikim's program. Thank you very much.
Thank you.
Ladies and gentlemen, before we move to the last keynote address, I would like to say thank you for those who already joined the giveaway by capturing their moment during today's webinar. We do appreciate it. And for those who haven't joined the giveaway, please don't wait any longer, join now. And the committee has set the attendance link on the Zoom chat box and YouTube description. Please ensure you fill in the attendance list as the record of your participations. Ladies and gentlemen, trust me, this talk will be as much as intriguing as the previous sessions. Now we have reached the last keynote speakers for this webinar, which presented by Dr. Alison Wilson from the University of College London. And her session will be led by the moderator from the Sampurna University, Indonesia. But before I give to Ms. Faradila. Ms. Faradila, good morning. Are you here with us?
Good morning, Ms. Lely.
Yes, thank you. Before I hand over this platform, I will read your short biography. Ms. Faradila Haryani, usually called Fani, is currently a mathematics lecturer from the Mathematics Education Study Program Sampurna University, Indonesia. She holds a bachelor degree in mathematics education from the State University of Surabaya, or UNESA, in 2013 and successfully obtained the 3 best GPA in her faculty. From 2013 to 2014, she worked as a mathematics teacher in SMA Al-Hikmah, Surabaya, before finally pursued her master's degree in mathematical modeling at the University of Birmingham, UK, with an LPDP scholarship. In 2015 until 2016, she started being a research assistant in UNESA. She also contributes to the book writing about best teaching practices during the pandemic, published by Dikmendikbud, the Ministry of Education and Culture, Republic of Indonesia. Her research focus is in educational technology. Ms. Faradila Haryani, I hand over this platform to you.
Thank you, Ms. Lely, for the nice introductions. Good morning, almost afternoon, everybody from Jakarta, Indonesia. So today I will serve as a moderator for our last keynote speakers. Yeah, after we have a very wonderful presentations for our 2 prominent keynote speakers before. Yeah, so our last keynote speaker will be Dr. Alison Wilson from University College London, UK. But before we move to her presentations, I would like to read her short biography. So Dr. Alison Wilson trained to teach secondary schools mathematics in the UK during the early 90s and became an advanced skills teacher who specialized in the use of innovative technologies. Her curiosity and creativity led her to work on a number of national and international curriculum development projects that aim to make mathematics accessible to all learners through engaging and context-based math activities that bring the concepts to life, especially algebra. Alison is also a principal research fellow at the UCL Knowledge Lab, University College London, and her research interests concern both how to scale and sustain the classroom uses of a dynamic mathematics technologies, alongside leading UCL research impact and engagement work as a founding member of the European EdTech Network. Her most recent publications is the open access survey paper accompanying the special issue of the journal ZDM, Mathematics Educations, on the theme Teaching Mathematics with Digital Technology. So, ladies and gentlemen, without further ado, please welcome Dr. Alison Clark-Wilson to deliver her presentations. So, Dr. Wilson, are you already here? Can you hear me?
I am. Thank you very much, Farida, and thank you for Ale for the introductions as well. Very good morning to everybody from UK. It's an early start for me this morning, but I hope I am awake enough to give you a good presentation. So,
all right. So, Dr. Wilson, I will offer 40 minutes for you to deliver your presentation. So, time is yours, please.
Thank you so much. I shall just bring up my slides. Well, good morning, everyone. And I'm really very delighted to be able to talk to you all this morning. And I'm going to focus a little on this, the title of the sessions today, which I've highlighted one of the words there, which stood out to me when I saw the theme for this webinar, which is how to better harness the potential of technology in learning mathematics. As you can see from my biography, I've been working in mathematics education for quite a number of years, and I've been working with technology for all of that time. I will say a little bit about my background in a moment, but this word better is very important to me because as the years have gone by and more technologies have arrived in front of us in the classroom, in our lives, it becomes so much more difficult to make the choices about which technologies to use, both for general teaching, but also for specifically for teaching mathematics. So the word better we will keep coming back to throughout the talk. So what I'd like to do is I'd like to just start by stepping back a little from the exact topic here and just to reflect a little on the purposes of mathematics education in school today. I mean, in 2021, where we have all gone through a year we did not expect to. Yes.
Can you please set your presentations into presentations mode? Because
I can. Let me just, sorry, I am on, let me just get my other screen. Sorry, I was on the screen for you.
All right.
Okay.
Better now. Thank you.
Okay, sorry. So I will start by reflecting on the purposes of mathematics education. And then I'd like to spend a little bit of time understanding this idea of the potential of how we might use some of these technologies so that we can learn mathematics with the technology as a tool to help us to collaborate, to communicate, to gain assessments and so on, but also through the technology, the way that the technology will really help us to understand those deep mathematical concepts that many people struggle to understand, and then how we harness this, how we learn from the past to make sure that we do not go for the, I would say, quick fixes, the quick solutions, but maybe concentrate on learning to use some of the mathematical tools that help to unlock the important ideas in mathematics. And we must always learn from the past. There are always lessons to learn so that as we move forward, we can avoid making very, very expensive mistakes that many countries and governments have made around the world as they've attempted to help maths teachers to use technology more effectively and more productively. So I'd like to take as a starting point the OECD document that was published in 2018, which set a vision for education for the future. And this was that the commitment was to help every learner develop as a whole person, fulfill his or her potential, and to help shape a shared future built on the well-being of individuals, communities, and the planet. And I share this vision. For me, education is very firmly for all learners everywhere, and we should be striving to provide an education that serves those learners for their lives as well as their future work lives, for which we have so many uncertainties. We know so little about the way that the jobs will evolve, the sort of work that will be needed by us as humans, particularly as the technology advances so quickly. When we have self-driving cars, we do not need taxi drivers. When we have automated restaurants, that we do not need waiters and waitresses. What will be the future for our children, for whom normally those would have been their jobs and their working lives? So the technology is chasing behind us to offer a world that maybe isn't the one that we really want for our learners. So this is an important starting point for me. And in terms of a vision, if we just think about the children who enter school in 2018, who will be joining the workforce in 15, 20, 25 years' time, we have to help them to abandon the notion that resources are limited, resources in the world are limited and they're to be exploited, and that together as the humans on the planet, we have to value common prosperity, sustainability, and well-being. Otherwise, we will have no planet that is a nice planet to live on in the future. And for this, we need our children to be responsible and empowered, placing collaboration above division. And I will come back to that for mathematics because it has some interesting implications. And put sustainability above short-term gain. So all the decisions we will be making as humans will need to be much more shared and collaborative, and it cannot be about the race to the top, which leaves others behind. So these values I subscribe to, and I think they are important values as we think about mathematics education. So if we think about that perspective, and we think about the mathematics education that we offer in our countries around the world, we do have two challenges really, because on the one hand, we want for our individual learners, their mathematics learning to be personalized, relevant, purposeful, social, involve others, not to be a lone subject, and for their learning to be recognized in the right sort of way. So this is important for the individual to feel engaged and connected and motivated to learn mathematics. But on the other hand, as countries, as governments, as society, we have to provide an education that is scalable. We can reach all of the children in a way that is equitable, that it is standardized to some extent. We want to know that people in one country are learning a similar sort of mathematics to another country, so that if necessary, they can migrate for work or they can migrate for study. As a society, we spend huge amounts of money on our education systems, so we need it to be accountable. We need to know that what we are spending to train our teachers, to develop our curricula, to develop our curricular materials, that it is doing good value for money. It is a good spend for the government, and everybody wants to somehow measure mathematical attainment in their countries to be able to hold schools and principals and systems to account. And we also like to compare. We like to know if we are doing better than one country or better than another country. But the problem is these two sides of this need have some conflicts, because we now have assessment systems around the world that assess a certain type of mathematics. And I'm not sure it's the sort of mathematics that is going to enable our children to reach some of these goals. I think in some ways we have a divisive mathematics system. That means that we set one child against the other in competition for the next place, for the best grade. And this doesn't serve to produce learners who want to collaborate if I am in competition with my collaborator in the school system. So we have some ways in that we are assessing mathematics that are in conflict with developing our learners to be collaborative and social in the way that they are learning the subject. But we have some solutions. It is a challenge we can rise to. So if we think about this for students learning mathematics, and I caught the end of Jolt's, Professor Lufixa's talk just then, and I know Jolt very well, and I've heard him speak many times. And this notion of curiosity and imagination is really very critical to students wanting to engage in learning mathematics. And you cannot make people be curious. You cannot make people have an imagination, but you can only do that by providing them with intriguing situations and contexts in which to want to explore the mathematics. I have been working in and around children for many, many years, and it is very, very unusual to find a small child, who is not curious. But it's very easy to see them go through the school system and for that curiosity to be suppressed. Because somehow having curious learners in your classroom as a teacher can be a challenge. I know I was a curious learner at school. I have to admit at this moment that in my own mathematics education, I was not my teacher's favorite pupil, because I did ask the questions, why and how and what if? And my teacher was not always so prepared or patient to take time to answer my questions. So I often wonder, the children who are curious are often suppressed a little, and in the end, they stop being curious because nobody is listening to their questions. So teachers have to have a special mindset to allow space for children to be curious, to be able to use their imagination, to become resilient, and I will come back to that, and to have self-regulation, to really understand about their own learning, how they learn best, and how sometimes we have to learn in ways that maybe doesn't suit us personally, but it is of benefit to the class or to society more broadly. It's really important in a mathematics classroom that children respect and appreciate ideas, perspectives, and values of others, because in some ways, the learning of mathematics is one big argument. We are arguing what is right, what is wrong, what is a proof, what is not a proof, what is a good justification, what is not so good. And so allowing children to express their ideas and their opinions about the mathematics is just as important as thinking about choosing mathematical contexts that are authentic, I would say, to the children's learning and the children's lives. And that takes me to the third point, because anyone who has been a maths teacher will know that part of the struggle we have is to support the students who are not at the top. So there can only be always some students at the top, and there are many, many, many students who are not in the first 10%, say, of attainment in a year group, in a class, in any situation. So for those other students, we have to help them to build resilience, to be able to cope with the fact that they will not always get the place in the top group or in the top class. They will not always be successful, but in my view, we never stop learning mathematics through our lives. So for learning mathematics, resilience is crucial, because every day we will face new challenges. And I think the amount of mathematics that the general public has learned over the last year in having to be able to read and make sense of statistics, what we mean by rates of disease transmission, all of these quite complex mathematical constructs have all been examples where populations around the world have learned a lot of new mathematical ideas in the face of the adversity that the pandemic has brought us. And then the final point here, and you notice I put it last, and you will see why I put it last, to know some relevant core mathematical content. And I'm going to focus in on the word relevant, because if you haven't seen, and I'm just going to jump out to a web link right now. If you haven't yet seen the Microsoft Maths tool, let me get that on the right screen for you. If this is a tool you haven't seen yet, it really will make you see how so much of the maths we teach now in school is already completely solvable by computers in a very quick and easy way. So let me take a very simple example. the sort that many students in school, I'm sure, will be solving in their classwork. If I type in 4x plus 6 equals 32, and I ask Microsoft Math Solver to solve it in far less time than most of us can do. This is a very simple problem. I could be much more complex. I have 3 different ways of expressing the solution. I even have a graphical solution. I have other content in terms of videos and concepts that might enable me to learn that more, and a whole load of other things from the World Wide Web. So if I can so simply solve any sort of problem that most children will meet in school mathematics, what content is it now valid for me to teach? If the answer to this problem is so trivial because I can get it from a machine in seconds, at what point will we not need to teach every child some of these techniques? In the same way, I know many of us would not have some of those very advanced mathematics techniques that we learned at university to our fingertips to use very quickly in a moment. At what point do we rethink what the content is? Because it's not whether or not I can solve 4x plus 6 equals 32 that becomes important. It is, what is this equation 4x plus 6 equals 32 representing for me in a real problem that I am interested to solve? What does it mean? What does that solution mean in the context of a graph or in a numeric context? Or is it more thinking about equivalence? What other families of functions might lead me to solutions of a similar type? So the fact that we have this technology, I haven't connected my phone for this particular task, but if I had connected my phone and written 4x plus 6 on a piece of paper, the app Microsoft Math Solver would let me point my camera at my handwritten equation and it would give me the same solution. So we've overcome the fact that handwritten mathematics is also challenging for computers, but the technology is advancing at such a rate that these sorts of problems become trivial if you have a mobile phone in your hand. And this really does mean we have to question, because children can now cheat very easily. You give them their homework, they have access to a mobile phone, they can hold their camera over the top of the problem, and the solution will be there in an instant. And they will learn this knowledge and share this knowledge with each other very, very quickly. So the relevance of the curriculum becomes very, very important. So moving on, what I'd like to do is to talk a little bit about the potential for technology as I see it. So one purpose there is it will solve maths for you. You don't need to know the maths because the technology will do that very, very quickly for you. So what else do we need the technology for? And these are some of my views. So first of all, it is undoubtedly an incredible tool for scaling to many, many children, many, many learners, a more equitable access to mathematics education. Now, the equity issue is a challenge because it then becomes whether or not you have access to technology to start with. But once you do, any child can access a free tool like Microsoft Math Solver, Khan Academy, GeoGebra resources. Everything is out there and it's very scalable. And a lot of it is freely accessible. So technology has supported scaling. We have seen this over the last year where schools have been closed in a way that I think even now we are only really getting to grips with. Technology will help us to build better learning content. So before, where we were fixed with paper books that we could not change every year or every 2 years, we had to invest a lot of money in them. They were static. There was nothing in the pages that moved or that gave insights into mathematical concepts in the same way we can using the dynamic technology. So this blend of digital and paper enables us to have a content that might be more personalizable, more relevant, more authentic for our learners. I come back to authentic because I know as a classroom teacher and in working with young people, one of the big questions that they ask with mathematics is, why do I need to know this? Why do I need to learn this technique? Why do I need to know this terminology? And so finding the justifications for that, for me, came from finding authentic contexts as a hook. And I like the phrase mathematical hooks to hook children's curiosity. How do we find the context and how do we react quickly on those contexts? The fact that the World Wide Web has so much relevant information that is immediately available gives us many contexts on which to create mathematical hooks for learners in thinking about mathematics. It's critical that technology is there to help us with communication and collaboration. And I think the key word here is supportive, because communication can be one way. And if we've sat in many, many webinars over the last year, how many have you been involved in where you have been an active learner other than listening? And remember, that is no different to the lecture in the class. So where are the opportunities to engage with the teacher, to engage with the other people within the session, to communicate and collaborate on the mathematical ideas? And I'm sure I wasn't in all of Zol's session, but I know you would have had opportunities to do that, where the work is on doing the mathematics. You are collaborating and communicating about the mathematics itself. I come to assessment and testing because there is no doubt that assessment and testing is a really important aspect of our mathematics education. But I've inserted the word valuable in there because more and more we are seeing that the sort of assessments and tests we have created are testing children on the sort of knowledge that Microsoft Math Solver can solve in seconds. So we need to rethink what is a valuable form of assessment and testing that meets the requirements of the state, of the governance, if you like, of the subject, that is standardizable and has all of those features, but that is also authentic and valuable to the learner. And to be practical, these are more project-based, teacher-assessed assessments that are not all taken by the children at the same point in time, in the same room, in silence. These are a different form of assessment that value more social working together in mathematics, and are probably more likely to be taken across a child's learning time when the child is ready, or when the group of children is ready. So rather than dictating everything is done at the same time, which is a very archaic way to do things. We know why. We needed to make sure that the children did not cheat. They were only using their brains as a resource. But none of us these days only use our brains as a resource. In any task we are working on, we will talk to others, we will look things up, we will weigh up different information and techniques to come to a good solution. So this for me is not authentic to the world that we live in. And as we move forward on our assessment system, I think because the technology helps us, we will be able to check in on what children know in mathematics, probably more regularly, but in smaller bites of understanding. So what are the really important concepts? Teaching and understanding aspects of working with fractions, say. We know this will not leave the maths curriculum, but the type of assessment you might do might be progressive. There might be some things you learn about fractions in the primary school that you do some assessment around. Later on, it becomes more difficult. We are working with algebra, with variables. There would be a different form of assessment, and it would not necessarily be a timed written test. For me, technology is really about stimulating interest in mathematics and providing opportunities for students to really get hooked, to want to engage with and learn mathematical ideas. And I like the approach of intriguing exploratory mathematical environments. These are essentially mathematical models that you have created that stimulate that curiosity and provide a very tangible context to get underneath the key mathematical ideas and constructs. So I think the best thing to do is for me to give you an example. And at this time, I am going to switch my technology. So I am going to stop sharing that particular screen. And hopefully I have my visualizer. And I think I have one. Yeah, I think you should be able to see a desktop. Can someone, Lely, can you just wave at me if you can see a circle and a pen on the screen?
Yes,
you can. Lovely. Okay, so I'm going to move over to my desk where I'm using a visualizer. And if I could turn all the things and show you, I have my iPhone on a little arm looking down on my table. And this is a free app that I use during the pandemic to teach mathematics when I needed to write and I needed to be able to show my mathematics through. So if I put my hand under here, this is my desk to the side of me. And I'm going to give you I'm going to start a task, which I would have loved to have done as a group in a room together, but unfortunately we can't. So I've got a circle of paper here. And this is a task that I like to use to introduce some of the ideas of geometry and thinking around how we start to build different models inside geometry software. So I'm going to be doing a task with a paper and pencil task, and then we're going to move to the software to look at how using the technology helps us to be a little bit more curious. So let me just explain the task first. So in this task, all the students or all of the learners start with a circle of paper, and I ask them each to put a dot on the circle of paper anywhere. Now I've put my dot here, but you might have put it over here and somebody else might have put it over here or over here. So we would all have a circle of paper with a dot on it, but our dots would be in different places, and that's quite important. So in this particular task, what I ask everybody to do is to start to fold their paper in a particular way. And the rules of folding are you must take anywhere on the circumference of the circle and fold over so that it just touches the center of the dot. Make a very firm fold and then unfold the paper and go again. So anywhere, doesn't matter where, fold over the paper and fold it back. And keep doing this. So I could have one there, a fold there. I can have a fold here. So we keep doing many, many, many folds. And what you start to get is something that we call an envelope of curves, where all of my fold lines are beginning to reveal something on the paper. So if I do a couple more and hold it up a little bit closer, you can see that I'm getting lots of lines, but where these lines are getting very close together, something interesting is beginning to happen. So the first word I would introduce to my learners is one of my favorite words, and I don't think a maths lesson will happen without this word, the word conjecture. What is your conjecture? What are you noticing? What would you like to say about anything that is emerging from your folding? And remember that yours will look a little different to the person sitting next to you as you are continuing to fold around. So if I take another example where I have some more folds, you can see if I keep going, there is something very interesting happening with this folds, and I'm very firmly getting a shape that is appearing in the center of, not in the center, but on my piece of paper. So I would invite you, those of you who would like to give me your conjectures as I was folding, conjectures about anything. So what are these lines? If you think about each of these fold lines and you had to describe to someone in the telephone using mathematical language what any one of these lines represents, how would you describe it to somebody? Do you see a shape emerging on that piece of paper there? Anything at all? What are your conjectures? So please do put conjectures into the chat, or I think it's into the Q&A in this case, and we'll come back to that later. So that's the beginning of the task. Now, I'll stop sharing that screen and now share a different screen. If you let me just switch. One of the arts of technology use is definitely managing multiple screens in Zoom, which is a skill I've certainly improved over the last year. So I happen to be using Geometry Sketchpad, and that is only because it is my dynamic geometry software of choice. I've been using it since the early 90s, and although other softwares have come along, this was the one I first learned. So on my software, it works in a very similar way to GeoGebra or Cabri Geometry or the other dynamic geometry softwares that are out there. And what this will let me do is model that situation. So I have done the groundwork. I've created a circle, and on that circle, I have shaded it grey so that you can see the circle. And what I'm going to do is simulate what I did in the paper example. So I'm going to put my dot, I think it was around about there on my circle. Okay, and this is where we need to do work together, because each time I did a fold, I asked you to sort of imagine a point on the circumference, and you were folding that point over to touch the point that was marked on the paper to create a fold line. So in mathematical terms, I have to imagine that I have a midpoint, and I am doing this very quickly because in a classroom situation, I would take children's conjectures, and it would take us quite a while to get to the point that these fold lines are in fact perpendicular lines that connect any point on the circumference with, I'm just going to change the display to make it easy to see. So this fold line is the line that was being produced as I was picking different points on the circumference. So you can see now, one advantage of the dynamic software is I've made a model of what I was doing, and all of these fold lines appeared on the page when as I folded round. Now, in the software, it happens very quickly, but I am not seeing them all. So I can use a feature of the software to construct, oops, let me just make sure I have, to trace that line. So as I move my point now, I can see many, many of my fold lines appearing much more quickly than I could fold them. And you can see much more clearly that there is definitely something interesting that is appearing here. And as I go further round, I hope those conjectures are coming in thick and fast, because if you know some advanced mathematics, you may know the name of this particular shape that is emerging here. You also might know the name of the dot that I put on the page to start with, but what we get is the most beautiful construction of, I'll give it to you, an ellipse. Now, I have one ellipse. The person sitting next to me would have a different looking ellipse, and the person sitting the other side, ellipse would be different again, because that first dot is an important variable within the construction. So just to take the software one step further, I'm going to erase those traces, and I'm going to stop tracing for now, because I want to show the real power of the software. As I was dragging that point around the circumference of the circle, I was actually constructing the locus of that perpendicular line. And what I can ask the software to do is to construct the locus of this dotted line as this point moves around this circle. And when I do that, I get the magic of all of those construction lines all at once. Now, by doing it this way, I have another thing I can change. Because I've built a construction, I can now see what happens when I move my original point to a different place. So what do we think will happen when I move this point closer to the center of the original circle? So it's taking a little bit of processing power for my computer here to stay up to date with me. Let me just click away and do that again. So as I move near to the center, something will happen. for me, the power is what I couldn't do with the paper. What if I move that point off the circle completely? I wouldn't have been able to do this with my paper folding, and we get this amazing phenomena, which is a rectangular hyperbola, which is part of the family of curves linked with the ellipse. And I have certainly created an opportunity for students at a more advanced level to explore the mathematics of this particular scenario. So I realize my time is coming to a close. So just to go back to my slides to finish off. And Lely, can you confirm you are seeing my PowerPoint slides again?
Yes, Miss, we can see your screens.
Thank you. So this idea of mathematical hooks, and there are many of them, that is just one, is that they do offer some authentic context. We had a real situation that we were working on something together, and through that we were using it to unpick the mathematics. There were many words to use in those conjectures that would encourage students to really understand their meaning. Circumference, point, center, perpendicular line, midpoint. These were all the words that we would have been describing, and I as teacher would have been introducing to help students to gain some geometrical understanding about circles, even at the age where they do not need to know what an ellipse is. I don't know many curricula that have the ellipse as a topic of study. So these amazing phenomena in mathematics, if you like, can be revealed to students in a way that shows them the aesthetic value as well as the potential for learning mathematics. I think intrigue is important, that notion of what happens if, or what if I change this. The idea of variance and invariance, what changes, what stays the same, are key ideas. Creative scenarios are really important. And also the challenge must be unsolved for the students. It is very demotivating to be always presented with things where the solutions are already known. So the idea that the students are on a journey that is to reveal or uncover the mathematical concepts is a very important part of a good mathematical hook. So a couple of points and then I will finish. We have learned from the past just how challenging it is to introduce mathematical technologies, particularly the dynamic type, as you've just seen, into classrooms around the world. We know that it is best done with supportive, collaborative professional development, coaching, learning communities, lesson studies. The format doesn't matter, but it matters that teachers work together to learn to use the technology, to learn to design the tasks, and to learn to use those tasks in the classroom takes a substantial amount of time. And I mean years, not months, and certainly not weeks and days. And that actually teachers can be really supported to design those valuable resources, the ones that are going to stimulate the mathematics in collaboration with the researchers, the technology companies, that collaboration is key. And that where things go wrong, where it is less successful, often the materials don't align with the curriculum in some way, or the exams, or the prevailing practices. People think it's too easy. I meet these people everywhere. They see the magic of the technology and they think a teacher could just use it like that. And the reality is it takes time. And unfortunately, top-down initiatives which just tell teachers what they should be doing or how they should be doing it, when it comes to technology, it has not been so simple because of the time and professional learning that is needed. So in thinking about how things move forward anywhere in the world, these are important ideas to have in mind. And this is the same everywhere. So I just took 3 examples from the literature, one from Mexico in the primary school, one from New Zealand in the secondary school, one from Canada in undergraduate education. These seem to be fairly universal factors teachers in that the professional development is key. We need to help build confidence first, to help teachers to, as Zsolt said, take a risk, be brave, and have the support to be brave, and then ultimately try and come together as groups of teachers so that we are not just the lone person who is really trying to move the use of technology forward, so that we really can harness its potential for the benefit of not just the learners now, but the learners for the future. Thank you very much.
Thank you, Dr. Wilson, for very wonderful and insightful presentations. Yeah, and now, ladies and gentlemen, we come to the questions and answer sessions. So I have actually resumed the questions from the Q&A. I will try to share screen so Dr. Wilson can see the questions. So the first questions. Okay, so the first question is, Dr. Alison, is there any step-by-step instructions of the Math Solver, the Microsoft Math Solver for the beginners? It seems difficult for the people who are not very familiar with this time technology. Thank you.
Yes, that's a very, very good question. So the Microsoft Math Solver is actually one that I've only come across in the last few months. So it's very interesting that one of my PhD students came to me and said, Dr. Alison, have you seen this? It does everything. Why are we still teaching children maths? I'm not aware of any step-by-step instructions. I think the intention is that it is fairly, I would say, obvious that you type the problem into the line. I think the app is more intuitive because you would just take paper and pencil maths. How we use it in teaching is a completely different matter, because on the one hand, you see this as a negative, something that is going to be, excuse me, something that might encourage students to teach. On the other, no, sorry, I've got 1 minute. I need to catch my voice is leaving me. 1 second.
All right. So in line with that, Dr. Wilson, sometimes
Okay, sorry about that. Too much talking. Yeah, okay. So yes, one of the problems with something like Microsoft Math Solver, we saw it when we had early called CAS software, computer algebra software, a few years ago, is you had to learn the syntax. You actually had the skills changed. You had to learn how to write what was paper and pencil mathematics in as one line of text to know what it is you want to solve. So there is definitely some support needed in learning how to use Microsoft Math Solver in a way that is useful to you. So obviously putting in a trivial calculation is straightforward, but when it comes to more advanced mathematics, particularly, for example, calculus or trigonometry, writing one line that would represent the solution still needs you to have a mathematical model. So the skills become different. The skills become how to present the mathematics to the machine in a way that is going to give you a solution that makes sense. So even Microsoft Math Solver would need professional development and learning for teachers to learn how to use it and make the most of it in their work or in their teaching.
Thank you so much for the answers. And for the next questions, I would like to invite Ms. Virastuti for sharing and asking directly to Dr. Wilson. Ms. Virastuti, can you start to asking directly to Dr. Wilson? Hello. So she's actually impressed with the comparing individuals versus sociable learning. So while we are waiting for Ms. Virasuti to directly ask questions to you, Dr. Wilson. So she asked about which one is actually more important, individual learning or pursuing good results in the standardized test. Because as we know, some schools is in Indonesia, last time we have actually the standardized test that every schools actually are eager to make their students are successful in the standardized test instead of making students are successful in their individual learning. So which one is actually more important, Dr. Wilson, according to you?
I think this is the critical question. And my personal view is that the current standardized tests go against really supporting the individual learners. So at the moment, these two things do not work together. And in my view, it makes it very difficult for teachers everywhere in the world right now to open the opportunities for students to do more productive, collaborative work of the type we've looked at, because there is such a huge pressure on them to help the students to do as well as possible in the standardized tests. So for now, the teachers who can go add that extra 10% in their teaching and find time to give students these sorts of opportunities, it is a risk, it is a challenge, because you only have a limited amount of time with the students. And I would be in the same position if I was currently teaching. My priority would be that my students did well, but I would try to adapt my teaching to find some time in the curriculum to show or to bring in some of these ideas. Maybe 5 minutes, 10 minutes in a lesson. I would just take a little bit of time out of or it might be my normal teaching style, to offer these sorts of opportunities. I think in the current context, it's very hard for teachers because really it is the assessment systems that will need to adapt. Otherwise, we will never have this a more collaborative societal approach to learning mathematics that really prepares our students to work productively and well in a more collaborative way in whatever work they go on to do, particularly those that go on into advanced learning in mathematical sciences, in STEAM, critical thinking and some of the mathematical skills we teach in school are really crucial to many, many roles out there in the world right now. So we have to work towards that. Many countries are reviewing their curriculum and assessment systems for quite big overhauls, I would say, over the next 10 to 15 years as we really try to grapple with this transition.
Thank you, Dr. Wilson. We still actually have another question, so I would like to move to another questions as well. So in the next questions is actually about how to encourage students to try solve math problems manual with understanding about the procedures and not only depending on the technology.
Yeah, I mean, this is where, for me, technology was always a hook in itself. When I was teaching trigonometry and my students were learning that if they type into a calculator sine of 50, a number comes back, that for me was a mathematical hook. We would then generate lots and lots of values of sine 50 from some paper activities and measuring. We would collate on the wall of the classroom a big table of all of the values of sine 50, and we would understand how or what sine 50 meant in the context of a trigonometric exploration. So anything a computer does for me is a point of curiosity. How did it do it? How did it do it so quickly? How do we know it's correct? These are the important questions. So even with my trivial example, I might even use Microsoft Math Solver to introduce solving linear functions of that or first order functions of that type. So I think it is a little in the mindset of the teacher, almost to say to the students, that this is all this technology is there, this is what it does, but how is it working? A human has programmed that technology. That is the most critical thing here. This technology didn't appear from outer space. We made it as humans. And I want my students to know that if they study mathematics and they learn how mathematics relates to many, many areas of our lives, they will have the knowledge and skills to build such technologies. We've had some fantastic projects in the UK working with the Scratch programming language to teach maths. We have a lovely set of curriculum materials for primary at the Institute of Education called Scratch Maths. And for me, this is teaching children the power of the computer to help them to understand the mathematical concepts. So I take these as opportunities. I don't see them as big challenges.
Thank you, Dr. Wilson. Maybe the last questions. I would like to invite Mr. Aljamadin Jodines, which actually proposed the questions through the Q&A in the Zoom. So, Mr. Aljamadin Jodines, is it possible for you to ask questions directly to the Dr. Wilson? All right. Okay. So it's about cheating. So yeah, because in the pandemic, the adoptions of the technology is actually being increased. So we cannot avoid the fact that cheating is actually easily being committed right now. So how actually technologies can prevent or even minimize the cheating that is also caused by the technology adoptions during this pandemic era, Dr. Wilson?
Yeah, I think this is it's a big issue, and it's a very real issue, and we're all facing it. I mean, in the UK, we have a big national exam in the next few weeks, and already students have a copy of the particular questions from the paper. They are already circulated on TikTok. That exam, in my view, is completely invalid because already we have this situation. But I think we are trying. I mean, I know many governments that are now spending a lot of money trying to develop technologies of the type that we use in cybersecurity to try to prevent cheating. So iris recognition on the laptop if I am doing an exam online, fingerprint recognition as you go into the exam room, obviously blocking technologies that stop signals so that you cannot. But it's the wrong approach. Okay, I personally think it is a different way around. At the moment, we do exams because we have to get the piece of paper to take us to the next line in the next part of our educational work-life journey, to get the job, to get the place at university. Now, if the exam certificate becomes increasingly less valuable because people do not trust that it is you, we will probably move to a more portfolio approach. So a portfolio is a collection of the work or the activity that you have done in mathematics, possibly taking in some of those assessments I mentioned earlier. That becomes a bit like your health record. In many countries, we have a digital health record that is collecting little bits about us through our lives. It can be shared with others. It can be integrated. It can be downloaded. We have a learning portfolio that comes with us through our lives that is the evidence of what we do. We don't then need to go and do an examination. Now, there will still be some examinations, but perhaps they will be done in a more real-time, authentic way. And then we will need to think about how we check on that. But if you think about it, the cheating is often access to the internet. Actually, this is really interesting that the other bit of knowledge people are looking for is somewhere on the internet. Now, finding knowledge is a really important thing. So in some ways, the resourceful people who cheat are also the people who would learn to use that technology for good, rather than in a negative way to cheat the system. So I think the systems have to change, is my response there.
All right. So, yeah. So if I can conclude, then providing more authentic assignments, is one of the ways to minimize the cheatings. It's also happening in my university as well. So the lecturers teams here is offering more projects rather than like giving assignments or even the examinations which has only one fixed answer. So it is also building their curiosity and also minimize the cheating level because of the internet access. So thank you, Dr. Wilson, but I think the time is already over. Thank you so much for your amazing presentations. Could you please make a short remarks or closing statements for us?
Absolutely, absolutely. I mean, I know you've had a really stimulating set of keynotes this morning, and first of all, very big thanks to the team at CMEO and CQM for the invitation. I think most importantly, that notion of resilience for us as teachers and for us as maths educators and maths students is the most critical thing. We are lifelong learners of mathematics. We have these amazing technological tools that just keep on revealing interesting ways for us to rethink not just the mathematics we've already thought we learned and understood, because I've learned far more since I left school than when I was at school, but also that it in itself is providing a foundation for us to really rethink what mathematics is in the 21st century and what mathematics education needs to be, so that we do build those children who really can grow up and thrive in the world that we are in.
Thank you, Dr. Wilson, for your times. Because it is still early in the UK, maybe you can continue to take a rest. Thank you so much. All right, so ladies and gentlemen, we have finished the last session for our keynote speakers from Dr. Alison Clark Wilson from the University College London. So thank you for the opportunity from the Siamo Kitab in mathematics for today's opportunity. And I would like to give the closing statements as well. So the technology is just a tools. So the main important thing we are as a teachers or as an educators needs to bring the technology to be in the meaningful learning for our students. So let's have a very high motivations and spirits to keep innovating in using technology so that we can build a meaningful learning for students. So thank you, everybody. I will give it back to the presenter. Miss Lally.
Thank you very much, Ms. Faradila, for a very wonderful sessions. Ladies and gentlemen, please give a round of big applause to Dr. Wilson and Ms. Faradila for these wonderful sessions. And once again, thank you very much, Dr. Alison, with your interesting topic. Hope to see you on another CQM Talks. And Ms. Faradila, once again, thank you for leading the sessions. Very nice. And for the last sessions, ladies and gentlemen, we would like to invite one of the panelists to give her closing statement of today's webinar. I'm pleased to invite Dr. Jonna Kigos. Dr. Jonna Kigos, the screen is yours.
Yes, am I audible? Am I audible?
Yes.
Yeah, okay. Thank you so very much for this opportunity. I would really like to thank CQM for organizing this wonderful webinar of various keynote talks on the theme, how to better harness the potential of technology in learning mathematics. There were 3 very wonderful and vibrant keynote talks since the morning, and each one has emphasized a very critical role that technology can play in learning mathematics, and especially in the context of this pandemic. So the first keynote by Mr. Tim Brzezinski was really highlighted very beautifully the key features of the Desmos software, which is extremely useful tool. And I have been through other Desmos sessions, but I have not been through one which so quickly has covered all the various features in such a short time. And also he highlighted the utility of Desmos both from the perspective of the teacher as well as that of the student. He highlighted various specific features such as the marble slides, and also showed some very interesting activities. The session was so hands-on that in a short time, I think the participants were able to sort of get at least the basic features of how to use the tool. So thank you for that. The second keynote by Professor Zsolt Lufixa of the Linz Center for Education, Linz, Austria, highlighted a wide range of research activities and projects which are conducted at their center. It was such a eye-opening session. Though, first of all, in fact, in my country also, there is a lot of talk about the STEM activities, and which is now integrating arts is now being referred to as the STEAM. So there were some beautiful examples of GeoGebra classroom resources. He focused on various research initiatives and which are taken up by different research scholars of the institution. He talked about how GeoGebra could be used in a wide range of devices. And he, of course, took us through the presentation. We also touched upon very important important topics such as what are the exam needs and how GeoGebra can cater to those needs. So he also highlighted the scientific calculator, the CAS calculator, the 3D aspect, the GeoGebra suite, and so on. And he also highlighted very nicely the augmented reality and the opportunities that augmented reality and GeoGebra together provide for visualizing and learning mathematics, with some very fascinating examples from architecture, which are being done by some of his research scholars. And what resonated with me in this session is the use of mathematical memes for teaching, which I think can really, as Dr. Alison would say, hook the students. Of course, there were very beautiful examples of origami, which we would like to take up. And I think workshops on these individual full day long workshops on these themes would go a long way in empowering teachers. The third keynote by Dr. Alison Clark, it really made us think as math educators, where she reflected on the purpose of math education, on learning mathematics with and through technology, and she kind of highlighted the subtle difference between the two. And in terms of harnessing the potential, she said that how mathematics education needs to be more personalized as well as scalable, more relevant and also standardized, more purposeful as well as accountable. And with these important terms, she highlighted the need for us to reflect on not just the use of, not mindless use of technology, but how technology can be used adequately and appropriately in the curriculum. She highlighted the needs of students and pointed to the fact that students will need more relevant mathematical content in the times to come. And she highlighted some nice examples on the Microsoft Solver. She brought out the importance of technology for scaling access to mathematics, building content, building important and interesting content of mathematics, and providing authentic context to students for learning mathematics. She also highlighted a very important thing, that we need a more relevant model of assessment, and we really need to move away from the models that we have been following so far. And the beautiful activity that she demonstrated on Geometria's Sketchpad on how the paper folding, the circular paper folding activity leads to a beautiful envelope, which is actually an ellipse. And I think this particular task really resonated with me because it can be done with various levels of students, and especially students who are learning conics, the topic of conics. And the term mathematical hooks is something very important that she mentioned, which needs to pull in the learner in the learning of mathematics rather than pushing the mathematical content on them. Just a caveat I would like to mention here that these digital tools have tremendous features, and we as educators need to be more careful on how we should emphasize on mathematical rigor and understanding, and on actually developing mathematical thinking, leading students to engage with processes of visualization, estimation, approximation, generalization, and there is a great role that she also mentioned, that projects rather than short assignments have a great role to play in building these processes of learning mathematics. Finally, I would like to say that there were very interesting and insightful questions from the audience. which led to very vibrant discussions after each of the 3 keynote talks. So to conclude, the webinar has really provided a great wealth of ideas for the practicing mathematics teacher, for mathematics educators, and teacher educators like me. So thank you very much for such a brilliant workshop, brilliant webinar session, and I hope there's a takeaway for everybody from these sessions. Thank you very much.
Thank you very much, Dr. Jona Kigos from the Lady Sri Ram College for Women India for delivering the closing remarks. Thank you very much. Ladies and gentlemen, before I close this webinar, I have several announcements for you. The first is about the e-certificate. This e-certificate will only be given to those who are eligible and will send to your registered email. And kindly check within 2 weeks ahead. And the second, please fill the evaluation form of this webinar to make some improvement or betterment for CCAM in the next webinar. And please don't forget to follow CCAM's social media for being always updated to CCAM's interesting yet challenging program. And thank you very much for participants who joined the giveaway of today's webinar. And we will announce the winner soon on the Instagram feed. Just stay tuned. Once again, let me conclude by saying thank you very much to all prominent keynote speakers, Mr. Tim Brzezinski, Professor Lufixa, and Dr. Alison Clark-Wilson for sharing today. And also thank you very much for all notable moderators, Dr. Nutaporn, Mr. Imam, and Ms. Faradila. And our sincere gratitude also for the panelists for today, Dr. Wahyudi, Professor Yaya Kusuma, Professor Alan White, Dr. Masita, Dr. Jona Kigos, Dr. Mariam Othman, Dr. Smardiono, Dr. Farida Nur Hasana, Dr. Susetyo, Ms. Reka Kaul, CCAM Specialist, Ms. Rini, Mr. Andi, Mr. Budi, Ms. Fatika, Ms. Janice, Ms. Sonia, Mr. Supriano. Thank you very much for your support. On behalf of the organizing committee, I'm Lely Dian Puspita, would like to thank you for joining our second international webinar and see you at the next international webinar. Stay happy and stay safe. Wassalamualaikum warahmatullahi wabarakatuh. Goodbye.
Profesor Alan.
Oke, Bapak.